Peace of mind and mental health. These are some of the most overlooked needs of the human experience. We all face mental breakdowns at some point. But when you're down, who do you talk to? A therapist? A close friend? If you've ever wished for someone to just listen, this is the app we are going to build together. Meet Aura 3.0, your AI mental health companion. In this video, we are going to build our very own AI therapist from scratch. Let me walk you through. First, we've got a clean and calming landing page that sets the tone for what Aura is all about. The app supports both light and dark mode for your comfort. Let's go ahead and sign up to access the dashboard. After signing up and logging in, you are welcomed with a beautifully designed dashboard. Here, you can track your mood, helping the AI better understand you over time. We've also added relaxing mini games like breathing patterns, Zen garden, mindful forest, ocean waves. Now let's try chatting with the AI agent. I'll ask, how do I manage stress? And just like that, Aura responds with thoughtful, supportive advice. But we're not just showcasing it, we're building this together. We'll deploy the backend on Render, the front end on Vessel, use MongoDB for data storage, integrate ingest for AI tasks, and use EchoAPI for testing endpoints. If this sounds exciting, stay tuned and let's build something meaningful together. Let's walk through how the AI therapy agent system works, using this diagram as our guide. At the very top, we have users. That's you and anyone else who wants to use the therapy app. You interact with the system through the web app, which is built using React. Think of this as the friendly website you see and use on your phone or computer. When you type a message or click a button, the web app sends your request to the backend, the main engine running the show behind the scenes. The backend is like the control center. It has several doors called API endpoints. The auth endpoint handles logging in and signing up. The chat endpoint is where your messages go for therapy conversations. Mood endpoint for tracking how you're feeling, and API activity endpoint for activity suggestions and tracking. Before anything happens, your request passes through a set of middleware. These are like security guards and helpers. For security, we use Helmet to keep things safe. CORS makes sure only allowed websites can talk to the backend. JSON passing helps the backend understand your messages, and for logging, we use Morgan to keep a record of what's happening. And error handling catches and manages any problems. Some actions, like sending a chat message or updating your mood, trigger special background jobs using something called ingest. Think of ingest as a smart assistant that handles important tasks in the background, so the main app doesn't get overwhelmed. There are three main functions it handles: process chat message, looks at what you said, and figures out the best response. Analyze therapy session, reviews your session for themes and progress. Generates activity recommendations, suggests activities based on your mood and history. Whenever the system needs to understand your message or come up with a helpful reply, it asks Google Gemini AI for help. This is like having a super smart advisor who reads your message and gives thoughtful advice. All your messages, moods, and activity suggestions are saved in MongoDB. Think of this as the app's memory, so it can remember you and your progress over time. Sometimes the system needs extra information, like new mental health tips or resources. Ingest services are like little helpers that go out, gather this info, and bring it back to the backend or database. Developers, the people building and maintaining the app, use tools like EchoAPI to test everything. This helps them make sure all the parts are working together smoothly without needing real users for every test. How everything connects. You interact with the web app. The web app talks to the backend through those API endpoints. The backend saves and retrieves info from MongoDB. When needed, the backend triggers ingest to handle background jobs. Ingest jobs ask Google Gemini AI for advice or analysis. Results and updates are saved back to MongoDB. Ingest services bring in new info to keep things fresh. Developers use EchoAPI to test and improve the system. For this project, we'll be using a few tools and technologies, and one of them is Cursor AI. You can download it for either macOS or Windows. It's very similar to VS Code. In fact, it's actually a fork of VS Code. So if you're already a fan of VS Code, you'll feel right at home using Cursor. We are using Cursor mainly because of its built-in AI features. It's an AI-powered code editor that helps you generate boilerplate code quickly, making the development process much smoother. It also comes packed with a ton of useful features. If you want to dive deeper, check out cursor.com. Next on the list is Next.js. It's a powerful React framework built specifically for the web. Think of it as React, but supercharged. It gives you features like server-side rendering, SSR, static site generation, SSG, and API roles, all built right in. That means faster load times, better SEO, and cleaner code architecture without having to configure everything manually. Next.js also supports dynamic routing, image optimization, and even edge functions, which makes it perfect for both startups and enterprise-level apps. Whether you're building a simple portfolio or a full-stack SaaS platform, Next.js gives you the tools to scale. We are using it in this project because it helps us build production-ready web apps with great developer experience, performance, and flexibility, all while keeping things organized and efficient. Now that we've got our framework in place with Next.js, let's talk about how the app will actually look and feel. And that's where shardcn comes in. Shardcn is a beautifully designed component library built on top of Tailwind CSS and Redux UI. It gives us access to clean, customizable, and accessible UI components. Everything from buttons and modals to forms and drop-downs without the need to reinvent the wheel. The best part? It's not a bloated component library. You only pull in what you need and you have full control over the styling, so your app still looks unique, not like every other Tailwind project out there. We're using shardcn in this project to help us move faster, stay consistent with our design system, and shape something that looks modern and polished right out of the box. Alright, so our UI looks good with shardcn, but let's be real, visuals alone aren't enough. We want our app to feel alive, not like a static page. That's where Framer Motion comes in. It's my go-to for adding smooth animations in React, whether it's a button that bounces a little when you hover or a page that fades in nicely. Framer Motion makes it super easy and fun to work with. And to add that extra layer of polish, we're using lucid icons, clean, modern, and just super easy to drop into any component. You can resize them, style them however you want, and they always look crisp. So yeah, animations plus icons equals a better experience for the user, and honestly, more fun for us as devs too. We're going to set up shardcn with Tailwind CSS. To follow along, head over to this URL so we're on the same page. On that page, we'll use a single command to create a new project. But before that, let's first create a folder and open it in Cursor AI to kickstart development. Cursor feels and looks very familiar, almost identical to VS Code. So if you've used VS Code before, you'll be right at home. Now, let's close the chat section in Cursor and fire up the terminal using Ctrl+tilde. I'm also going to split the terminal for easier multitasking. Next, we'll copy the yarn command from the website and paste it into the terminal. But boom, we hit an error because yarn isn't installed on this machine. No worries, let's try npm instead. You'll be prompted to install shardcn, so just type Y to continue. When asked to choose a framework, select Next.js. For the app name, I'm just typing a period. That tells the setup to use the current folder name as the project name. I'll fast forward this part since it might take a minute to install everything. When it asks for a color theme, I'm going with neutral, but feel free to pick whichever fits your vibe. And that's it. We've just set up Shard, CN, Next.js, and Tailwind CSS all in one go. Now that we've finished setting up Shard CN, Next.js, and Tailwind CSS, let's take a quick look at the folder structure we just generated. So you know where everything lives. Here's what your project should look like in Cursor Editor or VS Code. Let's break it down. First, we've got the app folder. This is where your routes and layouts live. Think of it as the heart of your app in the new Next.js architecture. Inside, you'll see layout.tsx, which wraps all your pages with shared layout components like headers or footers. And globals.css is where your global styles, including Tailwind-based styles, are defined. Next, we have the lib folder. This is usually where you put utility functions or shared logic. Right now, it just has a utils.ts file, but we'll be adding more here as the project grows. Public is where you store static assets, images, icons, or anything you want to serve directly. Moving down, you'll see files like package.json. This keeps track of all the dependencies and scripts for the project. TypeScript.json configures TypeScript for your project. Next.config.ts handles custom Next.js configurations. Alright, now let's start building out the actual components of this app. We'll begin with the header section, which includes the logo, navigation items, a theme toggle for switching between light and dark mode, and a sign-in button. Next up is the hero section. We're going to implement a really cool interactive slider here. Based on your selection, the gradient background color will change. It's clean, it's modern, and it's super fun to build. Then we've got the CTA, call to action section, which we'll add toward the end. So let's dive in. First, open the app directory and head into the page.esx file. Let's fire up the development server by typing npm run dev. This will launch localhost at port 3000, and you'll see the default boilerplate template from Next.js. We don't need that, so go ahead and clear it out. Let's start fresh by typing hello world, hit save, and boom. You should now see hello world showing up on localhost. That's the first step in what's going to be a much bigger journey. Now, we'll replace that paragraph with div and add the following Tailwind CSS utility classes: flex, call, mine, h, screen, overflow, hidden. Here's what each of those does. Flex turns the container into a flex box. Flex call arranges child elements vertically. Min h screen ensures the height is at least the full height of the viewport. Overflow hidden prevents unwanted scroll bars by hiding any overflow content. Cool. Now let's switch over to the layout.tsx file. This is where we'll structure the global layout for our app, meaning we'll import and render our header, footer, and any other global components here. Why? Because we want these components to appear across all pages. So it makes sense to include them in the layout, not on individual pages. Starting with the header component, this will contain the logo, navigation links, theme toggle, and maybe a sign-in button. You can actually preview what it's going to look like on the live deployed site right over here. Now let's switch back to localhost and continue building. Alright, it's time to start building out our header component. First, let's create a new directory inside the root of the project and call it components. This is where we'll store all the reusable parts of our UI. Keeping components in their own folder makes our codebase clean, modular, and easy to scale. Inside that folder, create a new file called header.tsx. In it, we'll define a default export for the header function. Just type export default function header and hit tab. This lets us easily import the component anywhere in our project without curly braces. Now let's switch over to layout.tsx and import the header component. This ensures the header appears across all pages, since the layout file wraps our entire application. That way, as we build, we'll see the header update in real time. Back in header.tsx, clear out the placeholder and start with a parent div. We'll give it some Tailwind classes: W full fixed, top 0, Z50 BG background, /95 backdrop blur. This makes the header span the full width, stay fixed at the top of the screen, sit above other elements with a high Z index, and have a slightly transparent background with a nice blur effect behind it. Inside that, create another div. This will act as a subtle border or visual separator under the header. Now let's add the main header content. We'll start by creating a div that will hold our logo and text. Inside it, we'll use Next.js's link component to wrap the logo and link it to the home page. So import link from next/link at the top, then use it like this. We'll add the classes flex items center, gap2, so the icon and text sit next to each other with a bit of space. Inside the link, we'll use an icon from Lucid React called audio waveform. Now let's install Lucid icons by running the command npm install Lucid React. Just paste it into the terminal. Once that's done, we can go ahead and import the icon we want to use in our component. This will serve as our app's logo. So import it at the top of the file and give it the classes h-7w-7. Text primary animate pulse gentle to give it a nice pulsing animation in our brand color. Next to the icon, create a div, and inside that add a span that says Aura 3.0. This is our logo text. You should now see both the icon and text on the screen in the top left of your app. Let's style the link element with flex item center, space x2 transition opacity, hover.opacity 80 to give it smooth spacing and a slight fade effect on hover. For the container of the text, we'll use flex call in case we want to add a tagline or secondary label later. And for the logo text itself, we'll apply text LG font semibold BG gradient to R from primary to primary /80 text transparent BG clip text to give it a bold look with a gradient that fades slightly at the end. Now scroll up to the outer wrapper of the header component and apply relative max W6 XL X auto PX4 to center everything. Limit the width and add padding on the sides. Finally, to space everything inside the header, including future nav items and buttons, we'll add flex H-16 items center justify between to the main content container. This sets a fixed height, centers all items vertically, and pushes them to opposite ends of the header. At this point, our layout is coming together beautifully. We've got a clean, responsive header with a logo, animation, and structure, ready for the next piece, the navigation and interaction elements. Now let's build out the navigation menu. Inside a div with the class flex items center gap 4, we are grouping the nav and other future elements, like a theme toggle or sign-in button, in a horizontal row with a little spacing between them. Inside that, we've got a nav in a horizontal row with a little spacing between them. Inside that, we've got a nav element, which is where all our navigation links will live. Notice we've added hidden MD flex. This means the nav is hidden on smaller screens and only shows up from medium screen sizes and up, perfect for responsive design. We're mapping over a nav items array, which contains our navigation links. For each item, we render a Next.js link component. We are using the key prop to uniquely identify each link using the href and then passing the href and label values dynamically. Each link has padding and font styling using Tailwind classes px-4, py-2 text-small font -medium text -muted -foreground. When you hover, the text color changes smoothly thanks to hover text foreground and transition colors. Right inside the link, we've added a span with the class absolute bottom 0, left 0 W, full H 0.5, BG primary. By default, it's scaled down with scale X 0, but when you hover over the link, the group hover scale X 100 class kicks in, creating a slick underline animation from left to right thanks to the origin left and transition transform. This gives our nav links a clean modern hover effect without needing any extra JavaScript, just Tailwind utility magic. You'll notice that nav items is underlined here. That's because we haven't created it yet. So let's go ahead and build. We're using an array because we might have multiple items in our navigation. Each item is an object, and inside that object, we have two properties. href is the link or URL the user will be taken to when they click. Label is the text that will be displayed in the navbar. So in this case, we're showing two items. One that links to /features and displays the text features. Another that links to /about and shows about aura. This approach is super helpful because instead of writing separate code for each link, we can just loop through this array and automatically create the nav links. It makes the code cleaner, easier to manage, and much more scalable if we want to add more pages later. Let's give this a save, and boom, you'll see the nav items rendered right here in the header. Let's enhance the top right part of the header by adding two key elements: a toggle for switching between light and dark themes, and a button that takes the user to the login page. In your header.tsx file, scroll down to where the navigation ends. Just after the tag, let's add a new div element. This div is going to hold both the theme toggle and the sign in button. We're applying flex here, so the child elements are laid out horizontally in a row. The items center class makes sure the items are vertically aligned in the center of the header, and gap 3 adds a little spacing between the toggle and the button. The two components, theme toggle and sign in button, haven't been created yet, so let's take care of that next. Inside your components folder, create a new file and name it themetoggle.tsx. This component will handle switching between light and dark modes when the user clicks the icon. Start the file with use client. This line is necessary because we're using client-side interactivity, and Next.js needs to know this component should run in the browser. Then add these imports. We're importing two icons, moon and sun, from the Lucid React icon set. These will serve as our visual cues for dark and light mode. The use theme hook gives us access to the current theme and a way to update it. And we're also bringing in the button component from shardcn UI setup. Now let's define the component. We're defining a function component called theme toggle. Inside it, we use the use theme hook to grab the current theme and a function called set theme that lets us change it. Now let's return the actual button. Here we're using our shardcn button component. The variant equals ghost makes the button background transparent, and size equals icon adjust the padding to fit tightly around an icon. The onClick handler checks if the current theme is light. If so, it changes it to dark. Otherwise, it switches back to light. Now we add the icons. The sun icon is visible by default. It has a height and width of 1 rem, H-4W-4. No rotation or scaling applied in light mode and fades out in dark mode. The moon icon starts off rotated and scaled down to hide it, but once the theme is dark, it rotates into place and becomes visible. The transitions are all handled by Tailwind classes for smooth animation. We also add, this span element is only visible to screen readers. It improves accessibility by describing what the button does for users who rely on assistive technology. Now go back to your header.tsx file and at the top type import theme toggle from theme toggle. This makes the toggle component available inside the header where we already placed it. Next, let's build the sign-in button. Inside the components folder, create a new folder called auth if it doesn't already exist. Inside that folder, create a file called signinbutton.tsx. At the top, add use client. We're doing this again because this button will be interactive on the client side. Now we add our imports. Here, we're importing the same button component and the link component from Next.js. The link component lets us navigate pages without refreshing. Now define the component. This interface allows the component to optionally receive custom styling via a class name prop. Then we write the component itself. We use as child so that the link replaces the default button tag that would normally be rendered. This way, the link looks and behaves like a button. The href equals forward/login makes the button navigate to the login page when clicked. Back in your header.tss, scroll to the top and add the sign-in button. Now both the theme toggle and sign-in button are set up inside the header, but theme switching won't work until we wire up the provider. To make the theme toggle work across the entire app, we need a theme provider. In the components folder, create a file called themeprovider.tsx. We import Next Themes Provider, which handles the logic of applying light or dark classes to the HTML tag. We also import React Node so we can type the children prop. Now define the component. We are wrapping the children, meaning the entire app, inside the Next Themes Provider. The attribute equals class tells it to apply class equals dark or class equals light to the element. Default theme equals system means it will match the user's OS setting, and enable system keeps that syncing in real time. Now we'll create a wrapper component to include our theme provider globally. In the same components folder, create a file called providers.tsx. Start with use client. Import theme provider. Then write the wrapper. This component simply wraps our app in the theme provider and applies it globally. The disable transition on change prop prevents flickering when switching themes. Now, one more thing before we finish everything up. Back to the layout file. We're going to wrap the provider around the layout file. We'll import it at the top and then scroll all the way down to wrap it around the children element, which will also include the header. We might then get an error saying provider doesn't exist in target module. This error occurs because we haven't saved the provider component. So let's move to the provider component and save the file. Once these fixes are applied and saved, our code begins working and the live preview now functions. When we toggle between the light and dark modes, we can see it operating perfectly and beautifully. You've now added a fully functional, responsive header with theming and navigation support, built from scratch and fully extendable. Now that we have the desktop navigation setup, let's make it responsive for smaller screens. We'll add a hamburger-style toggle button that appears on mobile and expands to reveal the mobile menu. First, we need a way to track whether the mobile menu is open or not. At the top of your header.tsx file, just inside the component, let's create a piece of state using the useState hook. Right after your import and before the return statement, this initializes a state variable called isMenuOpen, which starts as false. When it's true, we'll show the mobile menu. When it's false, the menu stays hidden. Set isMenuOpen is the function we'll use to update that state. Now let's add the toggle button itself. Scroll down to where we placed the theme toggle and sign in button. Just after those two components, still inside the same div, add this. This button only shows on mobile screens because of the MD hidden class, meaning it's hidden on medium and larger screens. On smaller screens, it appears. We use the button component with a ghost style and icon size to make it clean and compact. The onClick handler toggles the isMenuOpen state between true and false every time the button is clicked. Inside the button, we conditionally render an icon. If isMenuOpen is true, we show an X icon to indicate the menu can be closed. If it's false, we show the menu icon, 3 horizontal lines to indicate the menu can be opened. Now let's build the actual mobile menu that appears when this button is clicked. Just below the main header content, right before the closing tag of the header component, we'll add this block. This whole block only renders when isMenuOpen is true. That's why it's wrapped in curly braces with a condition. This is how we create the slide down effect on mobile. The content only appears in the DOM when it's open. The outer div has MD hidden again, so this mobile menu is only visible on small screens. It also has a top border to visually separate it from the header. Inside, we use a vertical nav with flex call to stack the nav links vertically, and space E1 adds spacing between each item. We loop through the same nav items array we used for the desktop nav. Each link gets padding, font styles, and hover states. When a link is clicked, we immediately set isMenuOpen back to false, so the menu closes after navigation. Now save your file. When you refresh and resize your browser to mobile width, you should see a hamburger icon on the right. Click it to expand the mobile menu. See the nav links stacked vertically. Tap any link to navigate and close the menu. See the Start Chat button if the user is authenticated. This gives us a fully functional, mobile-friendly navigation experience that matches modern UI standards and still feels lightweight and fast. Now that we have our theme toggle and UI components set up, it's time to define the look and feel of our entire app by customizing the design tokens, specifically the color variables used for light and dark themes. We'll do this using Tailwind's @layer-based feature, which allows us to define CSS variables globally, including things like background color, text color, button styles, and component behavior, all in one place. Let's go into our global CSS file. This is usually located at app/globals.css. Scroll down or create a block that starts with layer base. Inside this block, we'll define two major parts, root for the light theme and .dark for the dark theme. This root selector is where we define variables for the light theme. These are CSS custom properties that will be used throughout the app wherever Tailwind classes like BG background or text primary are used. Now let's define our light mode colors. These are designed to feel soft and calming, great for wellness, lifestyle, or minimalist applications. arc of these variables represents a design role. Background is used for the base page color. Foreground is typically used for text. Primary is your brand color, buttons, highlights, etc. Secondary is used for secondary buttons, chips, or tags. Muted colors are for subtle UI elements like backgrounds or dividers. Accent adds soft visual variety. Destructive is used for errors, warnings, or delete buttons. Border and input define form outlines and card edges. Rain is used for focus states like when a button or input is selected. Radius controls border rounding. Now let's define the dark theme. Below root, we'll add a .dark class. This class is applied to the element when dark mode is active, either through your theme toggle or system preference. Here's the full dark theme set. These colors are all slightly desaturated and soft. The background is a deep navy blue black, the foreground is a cool pale white, and all the accents lean toward greens, purples, and off blacks. It's meant to feel elegant and readable without being harsh on the eyes. Once you save this file, Tailwind will automatically pick up these variables. Anywhere you use a class like BG background, text primary, border muted, or hover BG secondary, it will be tied directly to these color definitions. This setup gives you full control over your app's visual identity. You can change your entire theme, both light and dark, by updating just this one file. And thanks to how Tailwind is structured, everything else, buttons, inputs, components, will follow this system without having to manually restyle them. Go ahead and hit save, reload your browser, and toggle between light and dark mode. You should now see your entire app styled with the new soft green, lavender, and slate color palette, beautifully consistent in both light and dark themes. Alright, let's build out the hero section of our landing page. This is the first thing users will see, and we want it to feel calming, welcoming, and emotionally interactive. We'll start clean. Open up app/page.tsx or wherever your home route is defined. First, since we'll be using client-side state and animation, we need to tell Next.js this component should run on the client. Inside this component, we'll be tracking the user's emotion selection and mounting state for animations. Let's import and use the required hooks. Just below the function line, we define our array of emotions. We're defining a list of different emotional states that users can pick from using the mood slider. Each object in this array has three things: a value, which represents how intense the emotion is on a scale from 0 to 100, a label which combines an emoji, and a short description like happy or peaceful. This is what will display in the UI. A color, which holds a Tailwind gradient class. We'll use this to visually reflect the selected emotion in the background of the hero section. This design allows us to map the user's slider inputs directly to a mood. So as they adjust the slider, we can update the background glow and UI to match their emotional state. For example, when the value is around 0, we'll show a sad face and use a soft blue tone. If it's 100, we show excitement with a pink glow. The gradient colors blend nicely into our UI and make the user experience feel emotionally responsive. This array gives us a scalable way to represent mood in both data and visuals, and we'll be referencing it throughout the rest of the hero section for interaction and design feedback. Now let's track which emotion is selected using React state. We will import this before using it. Then declare the state variables. We start with the slider at the middle value, 50 equals peaceful. The mounted state is used to trigger animations only after the component has loaded. Now, right after defining our emotions array, we need a way to track which emotion is currently selected based on the slider value, and also make sure animations don't run too early before the component is ready. Let's take a look at this part. This use effect runs once, right after the component mounts, because of the empty dependency array. Inside, we're setting mounted to true using the setMounted function. We'll use this mounted flag later to control animations from framer motion. So things only fade in after the page is fully loaded. Without it, animations might run too early or jitter while the DOM is still building. Now let's figure out which emotion the user has selected. Here's what's happening. We already have a state variable called emotion that holds the current value of the slider. What this line does is loop through all the items in our emotions array. It tries to find the first emotion where the difference between the slider value and the emotions value is less than 15. So for example, if the slider is at 47, it will match to the peaceful state, which is at 50, because the difference, 3, is less than 15. We use math.abs to make sure we're comparing the absolute difference, whether it's slightly above or below the emotions set value. And if it doesn't find anything close, which is rare, it falls back to emotions, which is our peaceful state at 50. This logic lets us say, hey, the user is somewhere around this mood level. Let's pick the closest one. And we'll use this current emotion value to update the background color and icons in the UI. It's a simple but powerful way to connect the slider's numeric value to a real emotion and design feedback that feels smooth and responsive. Now we're starting with our main hero section. This is the first section users will see when they land on the page. Let's look at the structure of this container. We're using a section tag to hold our hero content. The relative class lets us layer background elements inside it. Mean age 90%, view height makes the section take up 90% of the screen height, giving it a full screen feel. Empty 20 adds space at the top so it doesn't touch the header. We also added flex call to stack everything vertically. With item center and justify center, the content is perfectly centered, both sideways and top to bottom. Lastly, pi12px4 adds padding around the section, so it has some nice space on all sides. Altogether, this gives us a clean and centered layout that feels open and calming. Let's now add our glowing background effects. This covers the full section in set 0, pushes the layer behind everything, -Z10, and clips any overflow. Then we layer in our emotion-based glow. This creates a blurred circular gradient at the top left whose color updates based on the selected emotion. Next, we have a div that creates one of our floating background visuals. We position it using absolute, which lets us place it freely inside the section. We give it a fixed size of 400 pixels width and height and shape it into a perfect circle using rounded full. The background color is a soft version of our secondary color, made transparent with 10. To make it glow, we add blur 3XL, which creates that soft, dreamy blur. Then we push it to the bottom right using bottom 0, right 0. Finally, we add animate pulse to give it a slow breathing motion, and delay 700 makes it start slightly later than the other animations for a more natural feel. And one more div. This creates a subtle blurred overlay on top of the background for soft separation. Now we're going to render the ripple effect behind everything in our hero section. This ripple is that soft animated ring you may have noticed around the content on the live website. I'll show you exactly what I mean in a minute. Let's head over to the Magic UI website. As always, I'll leave the link in the description. In the search bar, type ripple, and you'll see the exact effect I'm referring to. To use this in our app, we first need to install it. So go ahead and copy the npm install command from the Magic UI docs and paste it into your terminal. Once it's installed, we can import the Ripple component into our project and start using it right away. We'll drop it right into our hero section just above our main content and give it a class of opacity 60 to make it blend nicely into the background without overpowering anything. Now when we save it and head back to the browser, we'll see that beautiful Ripple animation appear, and it looks incredibly clean and professional. It's a small touch, but it adds a lot of polish to our hero section. Next, let's animate our main content block to bring the hero section to life with subtle motion. To do that, we'll be using Framer Motion, a powerful animation library for React. But before we can use it, we need to install it. So let's open the terminal and type npm install Framer Motion. Once the installation is complete, we can now use it. Now we're going to bring our hero section to life with animation. To do that, we'll wrap our content inside a motion div. This lets us fade in and slide the content gently into view when the page loads. What this does is start the content slightly faded out, opacity 0, and pushed 20 pixels down, Y20. As soon as the component mounts, it smoothly fades in and moves up to its final position. The transition uses a soft ease out animation that feels calm and polished. The space Y8 adds spacing between each child, and text center centers everything inside. Inside this motion.div, the first thing we're placing is a subtle badge at the top, a kind of soft tag that introduces the app. It includes a small icon and some text. First, let's make sure we import the icon at the top of the file. Now here's the badge. We're using inline flex to lay out the icon and text side by side with a small gap between them, gap 2. The rounded border, soft background, and backdrop blur give it a calm, modern look. The waves icon has a built-in animation, animate wave, and the text gets a soft underline that animates on hover. A little touch of elegance without being too flashy. Right below that, we drop our main heading. This makes sure the headline scales nicely, starting at 4XL on small screens and scaling up to 7XL on large ones. The font plus Jakarta adds a bit of personality and friendliness to the typeface. Inside the H1, we split the phrase "find peace of mind" into 2 spans. We are using gradient text here, which creates that soft, color-shifting text look. The first span uses a horizontal gradient from primary to secondary, and the second span fades vertically using the foreground color. Both are clipped into the text using BG clip text and made transparent with text transparent. We even add a light text shadow to give it a bit more depth and contrast. Lastly, we place a simple paragraph under the heading. The max W, 600 pixels, keeps the paragraph from getting too wide, making it easier to read. MX Auto centers it, and we use text muted foreground to give the text a soft, calming color. The leading relaxed and tracking wide give it good line height and spacing, making sure it's readable and pleasant on the eyes. Let's keep going. Now let's build the emotion slider. So we start by wrapping everything in another motion.div. This makes sure the slider content fades in and slides up gently, just like the text above it. We also add some padding and max width so it's clean and centered on the screen. Inside this block, we start with a friendly line of text and the list of emotion icons. That little paragraph reminds the user that this is a safe space. We're using a soft color, text muted foreground /80, and smaller font to keep it gentle. Then we show 5 emotional states like down, content, and excited. These are stored in the emotions array. Each one has a value, a label, and a background color. We loop through them like this. This gives you animated emoji reactions. The selected emotion gets slightly larger and more visible. Scale 110 and opacity 100. while the others fade a bit. Clicking an emoji updates the emotion state. Each label is split into two parts, the emoji itself and the word like down or peaceful. We split them visually so the UI feels tidy. Next up is the slider itself. We don't have it installed yet, so let's head over to shard.cn and search for slider. Copy the install command, paste it into the terminal, and once it's done, we'll import it at the top. Here, we use the slider component from our UI library, and it controls the emotion value. As the user drags it, we update the state instantly. The background gradient behind the slider shifts with the mood. Each emotion has a corresponding color, and that color flows from left to right. The background has a soft blur effect and fades out toward the end, making it subtle but visually engaging. Just under the slider, we give a gentle prompt. We make it pulse slightly to draw attention without being loud. Finally, we wrap this section with a beautiful call to action button. This button uses a gradient background and has a soft shadow that becomes stronger when hovered. Inside, we add a little arrow icon from Lucid. It slides slightly to the right when you hover, creating a subtle sense of motion and progress. And just like that, the hero section is complete. So far, we've built a rich and responsive hero section that captures emotion through animation and color. Now let's scroll down a bit and build the features section, where we highlight the core benefits of using Aura. We'll build this inside a new section element and animate each feature using Framer motion. Right below your hero section, add this. This opens a new section on the page. Relative makes it a position container for absolutely positioned children later. Pi20 gives it vertical padding, and Pex4 gives some horizontal breathing space. Overflow hidden will help us control any overflowing blur or glow effects. Here we center our content using MX Auto and limit its width with max W6x large so it doesn't stretch too wide on large screens. This block introduces the section title and subtitle. We're wrapping it with motion.div to animate it when it enters the viewport. Text center centers all text. MB16 gives bottom margin for spacing, and space V4 adds vertical space between children. The heading uses a gradient applied to the text itself using BG clip text and text transparent. On dark mode, it adapts by using dark.text primary/90. This paragraph introduces what the section is about, styled for readability with max W2 XL centered using MX Auto, and given slight emphasis with font medium and text large. We're using a responsive grid to show each feature. This creates a flexible layout, 1 column on mobile, 2 on small screens, and 4 on large. Gap 4 gives spacing between cards. So we're going to add a new division element to prepare for displaying our features. This division will house the feature items, which we'll iterate through using a map function. Before that, we need to create the features array itself, which will be an array of objects. We'll scroll up and place this features array right under the existing emotions array of objects. The features array will contain properties for each item: an icon, a title, a description, a color, and a delay. The delay property is important. It controls how the animated division elements appear in sequence. The first feature will display quickly, while the last one will take a bit longer, creating a smooth stacked animation when the page loads. Within the main division, we use the map function to loop through all the items in the features array. For each item, we create an animated division, assigning a unique key and passing in various properties. Each card contains a nested division that holds the feature's icon, its title, and its description, arranging all the features neatly on the left side of the page. Now, let's create the final piece for our home page. the footer component, we'll create a new file inside the components folder called footer.tsx. This file will define and display the footer. We export the footer function. Inside, it returns the footer component, which has a class name for styling and vertical padding. Within the footer, there's another division with classes to center its content, arranging items in a flexible column with spacing. We also include a paragraph of text which will serve as the content for the footer. Finally, we move back to the layout.ts file. We call the footer component right after the main children element and import it at the top of the file. Once imported and saved, if we refresh the localhost on port 3000, we'll see the footer displayed all the way at the bottom of the page. Let's start by creating a root for our sign-in page. Inside your app directory, make a new folder called login, and inside that folder, create a page.tsx file. In the app router structure of Next.js, any page.tsx file becomes a web page automatically, in this case accessible at /login. Open page.txt and start with use client. This tells Next.js that this component will run in the browser, not just on the server. That's important because we'll use useState, which only works in the browser. Then bring in the necessary React tools and UI components. We're pulling in components that make our design clean and reusable. We also import icons, mail, lock to make the inputs visually helpful. As you begin building your login form, you might notice that the input and container components are underlined in red. This simply means they aren't installed yet and we'll need to bring them in from shard.cn. Before we fix that, let's prepare the files. Inside the components UI folder, let's create a new file called container.esx. Now in this file, let's first declare use client. This is important because this component will be used in the browser, and this directive tells Next.js to render it on the client side. Next, we'll import a helper function called cn from @/lib/utils. This function helps us merge multiple Tailwind CSS classes conditionally and cleanly. You'll see how handy it is. Now let's define our component props. We're extending the default HTML attributes for a div and adding a required children prop, which allows us to wrap any content inside this container. The container component takes in children, an optional class name, and any other props we pass in. Inside the return block, we render a div with some styling to center and pad the content nicely across screen sizes. The cn function helps merge our base styles with any extra class we pass in. That's all for our container. Now let's install the input component from shard.cn. Head over to the shard.cn website, find the input component, and copy the command. Paste it into your terminal to install it. Once that's done, let's move to the login page. Inside your login page component, start with a simple export default function. Login page, indents inside, return a div with the following classes: main hscreen w full, flex items center, justify center bg, gradient to br from primary, /10 via background to secondary, /30. Inside the card, we'll first add a heading section. This renders the sign-in title beautifully and responsively. Right under that, we'll add a paragraph. Text-based, text muted, foreground font medium. This provides a friendly subtext. Welcome back. Please sign in to continue your journey. Let's now prepare for the form itself. Before the form, we'll import state hooks for tracking user input. Now, when we move back to localhost port 3000 on the login route, this is how everything looks. We have the H1 title and the paragraph that says welcome back. Over here, we have these use state, email, and password. These hold the values typed into the email and password fields. Next, we add a form element with a class of space e-6, which gives spacing between each form section. Inside it, we start with the email input, wrap it in a div with the class space-e3 to keep spacing consistent. Now we add a label that says email, followed by a div that wraps the input field and icon. Inside that div, we position the email icon on the left using absolute positioning. Then we place the input component with props, ID equals email, type equals email, placeholder equals enter your email, the value and on-change track what the user types in real time. We repeat the same structure for the password field with a label, an icon, lock, and an input field that uses type equals password. The classes and behavior are nearly identical. Now we add the sign in button. Below the form, we add a footer that gives users a path to create an account or reset their password. Wrap it in a div with the class flex items center justify center gap to text sm. Then inside it, a simple span that says don't have an account, a link to /signup /styled with text primary font semi-bold, underline hover text primary /80, a dot separator, a link to /forgot password with similar styling. Everything is responsive and switches between light and dark mode seamlessly. Now let's move on to the sign up page. Inside the app directory, create a new folder named signup, and inside that, a page.tsx file. Because the sign up page is very similar to the sign in page, we'll start by copying the login page code. Now let's make our adjustments. First, add 2 new state hooks, one for username and one for confirm password. Update the heading to say sign up and change the paragraph to something like let's get you started. Now find the wrapper div where the name and email fields are arranged side by side. Update its class to flex_md flex row gap 4. This means on smaller screens the inputs will stack vertically, but on medium screens and up, they'll sit side by side. Next, wrap the name input in its own div with class name equals flex-1. This gives it equal width with its sibling inputs. Then add the label and input for the name, just like we did for email. Do the same for the email and confirm password fields. Finally, update the button text from sign in to sign up. And at the bottom, change the footer to say already have an account, sign in. Now everything is rendered beautifully on the screen, clean, responsive, and easy to use. At this point, you've built a fully polished sign in and sign up UI that looks modern and professional, is responsive across devices, has icons and clear input labels, tracks form values with React state, is ready for backend integration. Let's begin by setting up the dashboard page, the central place users will land after logging in. In your app directory, create a new folder called dashboard, and inside that, create a new file named page.tsx. Now let's open that file and write the basic scaffold for a client-side page. Use client, export default function, dashboard, and return a div with text hello dashboard. Let's walk through this line by line. Use client. This is a special directive in Next.js 13 that tells React, hey, this component will run in the browser, not just on the server. We add use client because we'll be using things like use state, use effect, event listeners, and other interactivity that only makes sense in the browser. If we forget this, those features simply won't work, and React will throw errors. So get into the habit of adding it only when you need client-side logic. We export a React component called dashboard. Inside it, for now, we are returning just a simple div that says hello dashboard. You should now see this output when you navigate to /dashboard in the browser. This confirms your route is working and the component is properly wired up. We literally can't see the text hello dashboard. So let's add a little bit of padding to the div. That's it. No imports yet, no logic, no styling. Just a clean, simple foundation to build from. Now let's take a moment to understand what this dashboard is actually for before we write any more code. Our dashboard is the user's personal mental wellness space. Here's what we'll be building in this section and why it matters. Welcome message. Personalized greeting and today's date so users feel grounded. Quick action buttons. Let users start a therapy session, log their mood, or check in with an AI assistant instantly. Wellness stats overview. Beautiful cards showing mood score based on their logs. Completion rate, how consistent they are. Total therapy sessions. Number of activities planned for the day. Mood modal. A pop-up where users can quickly rate how they're feeling. Games for anxiety relief. Interactive exercises for managing emotions. We won't just dump all the code in at once. Instead, we'll build this gradually and explain each component, each hook, and each style exactly when we need it. That way, you learn why each import matters. You get a feel for when to reach for use state, card, button, or motion.div, and you stay in full control of what's happening in the code. Now that we've set up the page and planned the layout, let's start building the header section of our dashboard. The goal here is to show a personalized welcome message and today's date. This helps users feel grounded when they land on the page. Let's bring in the bare essentials first. Open your app/dashboard/page.tsx and update the top. Why? We're importing use state and use effect because we want to display live up-to-date time on the page. Now let's set up the component state to track the current time. This code keeps the current time updated every second and also helps us show dynamic real-time dates and optionally clocks if needed later. Step 2. Add a simple header section. Now inside the return statement, replace the div hello dashboard with this layout. Adds spacing and a nice font hierarchy. Shows the current day in a human readable format like Saturday, June 21st. We're going to start by adding a container element right after our main div. Think of this container as a neat box that will hold all of our page's content, keeping things organized and responsive. Next up, we're bringing in some magic for smooth user experience. Framer motions motion.div. This special component is going to give us those beautiful fluid animations when the page loads or refreshes. Before we use it, remember to import motion at the very top of your file. You can see how it works in this snippet. Let's break down what's happening here. The initial property sets the starting point of our animation. We're telling it to start completely transparent, opacity 0, and 20 pixels to the left, x -20. Then, animate defines the end state. It will become fully visible, opacity 1, and slide into its final horizontal position, x0. The transition property dictates how long this animation takes, in this case, a quick 0.6 seconds, giving us that lovely smooth effect. Finally, class name equals space y-2 is a Tailwind CSS class that simply adds a bit of vertical spacing between any elements placed inside this motion div, making sure they don't look cramped. Now that we have our container and animation set up, let's build the main grid layout for our content. We'll kick things off by adding a div with a spacey -6 class. This class name equals space. y-6 is another Tailwind CSS class. It's similar to Space Y2, but adds a more generous vertical spacing, about 1.5 rem or 24 pixels, between its direct child elements. This helps create distinct sections on our page. Inside this div, we're going to create our responsive grid with another div. This class name is quite powerful. The grid part turns this div into a CSS grid container. Grid =1 means on smaller screens, our mobile first default, our content will stack in a single column. As the screen size grows, MD grid =2 will switch it to 2 columns on medium-sized screens like tablets, and LG.grid =3 will take it to 3 columns on large screens, desktops. Finally, gap 4 ensures there's a consistent 16 pixel space between all our grid items, giving everything some breathing room. Within this flexible grid, we're going to use the card component from Shadcn UI. If you haven't installed it yet, now's a good time. We've done this a few times in previous tutorials, so you should be familiar with the process. Here's the code for our card. These Tailwind CSS classes really bring our card to life. Border primary /10 adds a subtle border using a light shade of our primary brand color. Relative is important because it sets the positioning context for any absolutely positioned elements inside this card. Overflow hidden is a small but mighty detail that ensures any content extending beyond the card's boundaries gets neatly clipped, keeping things tidy. And group, that's a special Tailwind class that allows us to apply styles to elements within this card when the card itself is hovered, letting us create cool interactive effects. Immediately following that, we have a div that creates a cool visual effect. This div generates a soft gradient overlay on the card. Its absolute inset 0, meaning it's positioned to cover the entire area of its relative parent, our card. The BG gradient to BR creates a background gradient that flows from the top left to the bottom right. The colors from primary /5 via primary /10 to transparent define a subtle fade, starting with a very transparent primary color, then transitioning to a slightly more visible primary, and finally becoming completely transparent. It adds a gentle, luminous quality. Then comes the actual content area of our card. The P6 here simply adds 24 pixels of padding on all sides inside the card content, creating a nice buffer around our content. Relative again sets a positioning context, but this time for anything absolutely positioned within this content section. Inside this card content will include this button uses Shadcn UI's default variant for its base styling. The class name uses a utility cn to combine various Tailwind classes. wfull makes it take up the full available width, and P6 gives it generous padding, making it nice and tall. Group button is another special Tailwind class, creating a specific group for this button, allowing for hover effects on its internal elements. We are applying a horizontal background gradient from a slightly transparent primary color to a full primary color, which then subtly reverses on hover for a nice visual flourish. The transition all duration 200 ensures all these changes animate smoothly over 0.2 seconds, and group hover.translate 2 pixels makes the button lift slightly when hovered, adding a subtle interactive feel. Next, we'll arrange the divs for our mood tracking and activity logging features. We'll create another div for these. This sets up a 2-column grid with a 12-pixel gap, perfect for placing 2 smaller, equally sized elements side by side. This button uses Shadcn UI's outline variant. We're making its content a flex call container, meaning everything inside will stack vertically. It has a fixed height of 120 pixels and specific padding. The group cheat mood class again enables hover effects, specifically making the button's border primary /50 on hover. We've also included the same smooth transition. The inner div creates a small circular icon background, this time in a lovely rose color, with the heart icon perfectly centered, and MB2 adds a small bottom margin to separate it from the text below. A quick note on icons: if you see any missing icons, just remember to import them using the Lucid React components. We've covered this many times, so it should be second nature by now. Finally, here's the button for checking in on activities. As you can see, this button is structured and styled very similarly to our track mode button, but it serves a different purpose and uses a blue themed icon for a subtle visual distinction. The Tailwind CSS classes for layout, sizing, and hover effects remain consistent. Once we close off the main card component, we are ready to create a brand new section, the Overview Card section for displaying wellness metrics. To do this efficiently, we'll start by defining an array of objects called Wellness Stats. This Wellness Stats array is a beautifully structured list of data, with each object representing a single wellness metric we want to display. Each object clearly defines a title like mood score, a value which can dynamically pull data from daily stats for things like mood percentage or session counts, falling back to no data if unavailable, an icon from Lucid React, specific color and BG color Tailwind classes for consistent styling, and a description to give context to the metric. This setup makes it incredibly easy for us to loop through and render these statistics dynamically. Now scroll down to where you see your overview comment in the code, and let's create a card and its card header with these classes. Inside our card header, we'll create a div to help with alignment. This div acts as a flex container, ensuring that any elements inside it are item center, vertically centered, and justify between, spaced out horizontally, which is perfect for our title and description. We're going to use card title and card description here. If you haven't already, make sure to import these components at the top of your file. Also, while you're up there, let's import format from datefns. This handy utility will help us display dates in a nice, human-readable format. The card title and card description components from Shadescn UI give us semantic structure and default styling for our card's heading. The format, new date, uses the datefns library to take the current date and format it into something like June 28th, 2025, making it easy to read. Right after the card header, we'll create our card content section. Inside it, we'll have a div to set up another grid. This creates a 2-column grid with a 12-pixel gap, specifically designed to neatly display our individual wellness statistics side by side. Now inside this div, we'll loop through our wellness stats array and display each one on the UI. This is where that structured wellness stats data really pays off. Here, wellnessstats.map iterates over each statistic, creating a div for each one. The key equals stat title is vital for React to efficiently render lists. The class name is dynamic, p-4, rounded LG gives padding and rounded corners, transition all duration, 200 hover colon scale. Dash 1.02 makes the card slightly enlarged by 2% on hover with a smooth animation. And stat.bg color applies the unique background color defined for each statistic. Inside each stat card, we have a flex container for the icon and title, dynamically rendering the icon and applying its specific color. Then the value is displayed prominently with large bold text, followed by a smaller muted description. It's a clean and effective way to show off all those important metrics. Moving on, right after this div containing our wellness stats, we're going to set up a content grid specifically for our games. First, create this div This establishes a responsive grid, one column on smaller screens, and then it expands to 3 columns on large screens, LG, and above, with a 24-pixel gap between grid items. Inside that, we'll nest another div. This div uses LG : span-3 to tell it to span all 3 columns when the screen is large or bigger. This is perfect for a heading or a large component that needs to take up the full width of the grid. Spacey6 adds 24-pixel vertical spacing between its children. Now, before we jump into building the actual game components, our anxiety games, let's quickly set up the dialog for mood tracking. For this, we'll need to import these components at the top of your file. You'll also want to make sure you've installed these from shadcn UI. Just copy the command and paste it into your terminal, as we've done many times before. Scroll all the way down in your file, and let's create a section for our mood tracking modal. You'll notice we don't have show mood modal and set show mood modal states defined yet. Go ahead and create these states using useState at the top of your component. The open prop controls the dialog's visibility, and onOpenChange is a callback that will update our state whenever the dialog's open status changes, like when the user closes it by clicking outside or pressing escape. Inside the dialog, we'll add its content. The dialog content wraps the dialog's inner elements. Class name equals sm.maxw 425 pixels. Ensures the modal isn't too wide on small screens and up. Dialog header groups the dialog title, how are you feeling, and dialog description. Move the slider to track your current mood, giving clear instructions to the user. We'll leave a space inside the dialog content for the actual modal form, which we'll build next. Next on our list is the activity logger. You've seen how it looks on the deployed website. We'll tackle the implementation for that a little later. For now, let's focus on setting up the anxiety relief games. Inside your components directory, create a new folder called games. Then inside that new games folder, create a new file named anxietygames.tsx. Within anxietygames.tsx, we'll need to import a bunch of things. Following our imports, we'll define a constant array called games. This array will hold the structured data for each of our anxiety relief games. Just like our wellness stats, this games array provides a neat way to organize all the information about each game. Its unique ID, a descriptive title, a brief description, the relevant lucid icon, specific color, and BG color classes for visual consistency, and an estimated duration. Next, we'll define the props that our anxiety games component will accept. This anxiety games props interface specifies that our component can optionally receive an on-game played prop. This prop is a function that, if provided, will be called when a game is launched. It expects the game's name and description as string arguments and is designed to handle asynchronous operations, such as logging the game activity to a database. Now, let's declare our main anxiety games functional component. In this component, we have two main states, the selected game and the show game state. These states help us track which game has been chosen and which game should be currently displayed. Next, we'll implement a function specifically designed to handle actions when a game is clicked. When handle game start is triggered, it first updates selected game with the ID of the chosen game and sets show game to true, which will cause the game modal to open. It then checks if the on-game played prop was provided. If so, it attempts to call that function to log the activity, gracefully handling any potential errors. To display the correct game within our modal, we'll use a helper function called renderGame. This renderGame function is straightforward. It uses a switch statement to look at the selected game state and then renders the corresponding game component: breathing game, Zen garden, forest game, or ocean waves. If no game is selected, it simply returns null. Initially, our anxiety games component will simply return the title and description of the games, but we're about to make it much more dynamic. Back in your dashboard page .tsx, you'll want to import anxiety games and integrate it. Once you do, you'll see the title Anxiety Relief Activities with its description rendered on the right side of the screen. Now let's return to anxietygames.tsx and make it render all the game activities in a structured way. We'll start by adding a div that sets up a grid for our game cards. This creates a responsive grid showing one column on small screens and two columns on medium screens, MD, and up with a 16 pixel gap between them. Inside this grid div, we'll use the map function to loop through our games array and render each game as a clickable card. For each game, we wrap it in a motion div from framer motion. Key equals game ID is crucial for React efficient rendering of lists, while hover equals scale equals 1.02 makes the card subtly enlarge by 2% when the user hovers over it, and while tap equals makes it slightly shrink by 2% when clicked, providing excellent visual feedback. Inside each motion.div, we'll use a shadow card component, applying conditional styling to highlight the active game. This card has a light primary border. On hover, its background will change to a very light primary color. The transition colors ensures this is smooth. Cursor pointer provides visual feedback that is clickable. The magic happens with the template literal. Selected game equals game ID, ring to ring primary. This line checks if the current game.id matches our selected game state. If it does, it adds a 2 pixel thick ring around the card using our primary color, visually indicating which game is active. Inside this card, we'll use card content to display the game's icon and details. The card content has 16 pixels of padding. Inside, a flex container lays out the icon and text. The div with dynamic background color and color creates a rounded XL, slightly rounded square background for each game's icon. The flex1 div then holds the game's title bolded, a smaller muted description, and a line displaying the music to icon alongside the game's duration. Once this is rendered, you'll see all the games beautifully displayed on the right-hand side of your application. Now, let's add the onClick event handler to our card component. This will trigger our handle game start function when a card is clicked, and you'll immediately see that vibrant ring appear around the active game. Finally, let's integrate the dialog to display the game itself when it's clicked. This dialog will open when show game is true. Its dialog content is set to a maximum width of 600 pixels on small screens and up. The dialog title dynamically displays the title of the selected game. And the magic happens with render game, which is where our helper function renders the specific game component, like breathing game, right inside this modal. Now for the exciting part, it's time to create the actual games. We'll start with the breathing game. Inside your games folder, let's create a new file called breathinggame.xx. At the very top of breathinggame.tx, remember to add use client to ensure it runs on the client side. Then import all the necessary modules. We define total rounds as a constant, making it easy to adjust the game's length later. Inside our breathing game component, we'll manage several states using useState. These states track the phase of breathing, inhale, hold, exhale, the progress within the current phase 0 to 100, the current round, whether the game is complete and if it is paused. The core game logic lives in a useEffect hook. This useEffect is the engine of our breathing game. It runs whenever the phase, round is complete or is paused states change. It immediately stops if the game is complete or paused. Then it sets up an interval based on the current phase, inhale, hold, or exhale. Each set interval incrementally updates the progress. When progress hits 100, it either transitions to the next phase, increments the round, or marks the game as is complete if all total rounds are finished. The return, clear interval timer part is crucial for cleanup. It ensures that the timer is cleared whenever the component unmounts or the effects dependencies change, preventing memory leaks and unexpected behavior. We also need a way to reset the game. The handle reset function simply sets all our game-related states back to their initial values, allowing the user to start a new game. Now, let's look at the return statement. This div is the main layout for our active breathing game, centering all its content within a fixed height and with generous vertical spacing. We use animate presence mode equals weight to smoothly transition the breathing phase text and circle. The inner motion.div uses key equals phase, so framer motion knows when to animate a change. It fades in and out, opacity, scale as the phase changes. The animated breathing circle itself is built with a relative container. The inner motion.div has a bg primary /10 and rounded full styling, and its animate property dynamically changes its scale based on the phase, expanding for inhale, shrinking for exhale, holding for hold, simulating the breathing action. This animation is slow and smooth. Duration 4, ease in out. The wind icon is centered within this circle. Below the animated circle, an H3 dynamically displays the current instruction. Breathe in, hold, or breathe out. Then Cn progress bar visually tracks the progress within the current phase. Finally, a div displays the current round out of total rounds. Below that, a button allows the user to pause or resume the game, dynamically changing its text based on the is paused state. Back in anxietygames.tsx, you'll now need to import breathing game at the top of the file, and then make sure to return it within the render game function for the breathing case. Now, when you click on the breathing game button on your local host, you should see the game beautifully animating in the modal. Feel free to play around with the total rounds constant to see how it changes the game's duration. Our next calming experience is the Zen Garden game. Let's create a new file inside your games folder called zengarden.tsx. Start this file as always with useClient, and then import our essential React and Framer motion components. Next, we'll define an array of items that our users can place in their garden. This items array clearly lists the decorative elements available for the Zen Garden, each with a type for internal identification and an icon, an emoji for visual representation. Now let's define our Zen Garden functional component. Inside, we'll manage two important pieces of state. The placed item state will be an array holding all the items that the user has clicked to place on the canvas. Each item in this array will not only have its type and icon, but also its X and Y coordinates to remember where it was placed. It starts as an empty array. Selected item keeps track of which item from our items array the user has currently chosen to place. It starts with the first item, the rock. Here's the function that handles clicks on our garden canvas. When handle canvas click fires because the user clicked on our canvas div, it first figures out the exact X and Y coordinates of the click relative to the canvas itself. Then it updates the placed item state by taking all the existing items and adding a new item, which is a copy of the selected item along with its new X and Y coordinates. Now let's look at the JSX our component returns. We'll start with a main container div. This div simply adds 16 pixels of vertical spacing between its direct children, keeping our item selection buttons and the canvas nicely separated. Next, we'll loop through our items array to render the selection buttons for our garden elements. This div uses flexbox to justify center, horizontally center our item buttons and adds a 16 pixel gap between them. Each item in our items array gets its own motion dot button. The while hover and while tap framer motion props give us those satisfying enlarge on hover and shrink on click animations. When a button is unclicked, it updates our selected item state. The class name uses a conditional check. If this item is the selected item, its background becomes a slightly darker primary color, BG primary/20. Otherwise, it's a very light primary color, BG primary/5, giving visual feedback about the current selection. The emoji icon is displayed prominently with text 2XL. Finally, we have the main canvas area where users will click to place their garden items. This segment renders a foundational DOM element functioning as an interactive canvas. Its properties include relative positioning, full width, a fixed height, a semi-transparent background, rounded borders, and a pointer cursor for user interaction, with content overflow hidden. And on click, event handler, handle canvas click, is dynamically bound to this element. Within this primary element, an array iteration method processes a collection of placed items. For each item in this collection, a component instance, likely from a motion animation library, is rendered. This component instance is uniquely identified by a key property derived from its index. It's configured with initial and animated transformation state properties, specifying a scaling in visual effect from a 0 scale to a full scale of 1. Inline styling applies absolute positioning with left and top CSS attributes precisely determined by the item's coordinate data, incorporating a slight offset. A CSS class is applied to control the text sizing of the rendered content. Finally, the icon property from the current item's data object is directly rendered as the visual content within each animated component instance. Now let's move back to your anxietygames.tsx file. You'll need to import Zen Garden at the top and then make sure to include it in your render game function for the garden case. With that in place, you can now enjoy your interactive Zen Garden game. Our next immersive experience is the forest game. To begin, let's create a new file for it. We'll import useClient and all other necessary elements. We'll also define a constant for the meditation duration, setting it to 5 minutes expressed in seconds. Now let's define and export our forest game component. Inside this component, we'll manage several states: is playing, a true or false value to track if the sounds are currently playing, volume, a number from 0 to 100, controlling the audio volume. Progress tracks the percentage of the meditation that has been completed. Time left, the countdown for the meditation in seconds. Audio elements. This is a use state hook that creates and holds references to audio objects for our nature sounds, including birds, wind, and leaves. Remember, you'll need to create a sounds folder inside your public directory and place these MP3 files there. You can grab these files from my GitHub repository. We also have a use effect hook specifically dedicated to setting up our audio and ensuring proper cleanup when the component is no longer in use. This use effect runs just once when the component first mounts. It loops through all our audio elements to set the loop property to true so they play continuously, and set the initial volume based on our state. The return statement is a crucial cleanup function. When the forest game component is removed from the screen, it ensures all audio elements are paused and reset to the beginning, preventing sounds from playing in the background. Another use effect handles real-time volume adjustments. This hook listens for changes in our volume state. Whenever the volume slider is adjusted, it iterates through all the audio elements and updates their volume property accordingly. The main timer logic for our meditation is controlled by this use effect. This use effect starts an set interval that runs every second, but only if the game is playing and there's time left. It decrements time left and calculates the progress percentage. Just like before, the return gains clear interval timer, ensures the timer is stopped when the component unmounts or these dependencies change. We need a function to toggle play pause for our sounds. The toggle play function simply checks if it's playing. If true, it pauses all the audio tracks, otherwise it plays them. It then flips the eyes playing state, which will update the UI, like changing the play pause button icon, and the helper function to format our time display. Format time takes a number of seconds and converts it into a MMSS string to ensure seconds are always 2 digits. Now let's look at the JSX our component returns. We'll start with the main container div. This div acts as our main layout, centering its content both vertically and horizontally within a fixed height of 400 pixels and adding generous vertical spacing, space E8, between its elements. Inside, we'll place our animated forest icon. This div creates a captivating animated pine tree icon. The motion.div applies a continuous subtle animation. Scale 1, 1.05, 1 makes the tree gently pulse, grow and shrink, and rotate. 0, 1, 1, minus 1, 0 makes it subtly sway back and forth. This animation runs over 4 seconds, duration 4, repeats infinity times, and uses an ease in out transition for smoothness. The inner div creates a blurred glowing background in a green gradient, adding to the forest ambience, and the tree pine icon itself is centered within. Below the animation, we have our control section. This entire block of code is neatly contained within a div that has a fixed W-64 width and space Y-6 vertical spacing. First, we have the volume control. A div with flex justify between displays the volume label and the current volume %. Below that, another flex container holds a conditional icon, volume X if volume is 0, otherwise volume 2, and our shadcn UI slider component. This slider is bound to our volume state, allowing users to smoothly adjust the sound level. Next, a shadcn UI progress bar visually represents the meditation's completion %. Finally, we have the play pause and time display section. This div uses flex items center justify between to lay out the remaining time, the play pause button, and the total meditation duration. The format time left displays how much time is left, while format time meditation duration shows the total length. The button is styled as a circular outlined icon. Its on-click event calls our toggle play function, and its icon dynamically switches between pause and play based on the is playing state. Now you'll need to go back to your anxietygames.tsx file, import forest game at the top, and then add it to your render game function for the forest case. Once that's done, you can test it on your local host, adjust the volume, and enjoy the calming forest sounds. Just a heads up, the Ocean Waves game won't be created in this specific tutorial. I'll have separate tutorials dedicated to building React.js and Next.js games, so stay tuned for that. Now let's create the mood form component. This will allow users to track their current mood. Inside your components directory, create a new folder called mood, and inside that, create a file named moodform.tsx. Start moodform.tsx with use client, and then import these modules. Next, we'll define the props that our mood form component will accept. This mood form props interface declares an optional onSuccess prop, which is a function that will be called if the mood submission is successful. Now, let's define our mood form functional component. Inside this component, we'll manage a few states. Mood score will hold the user's selected mood initialized to 50. IsLoading will tell us if the form is in the process of saving data. And router is our Next.js hook for programmatic navigation. We'll define an array of emotions that correspond to different mood scores. The emotions array provides the emoji and descriptive text for various mood levels. Current emotion is a clever bit of logic. It finds the emotion whose value is closest to our mood score within a threshold of 15 points to display the most relevant emoji and description. If no close match is found, it defaults to the neutral emotion. This is similar to what we've done on the dashboard, so we won't spend too much time on it. Now, let's look at the JSX our mood form component returns. This entire div serves as the main container for our mood form, providing generous space-6 between its sections and vertical padding. The emotion display section simply centers and styles the current emotion.label, the large emoji, and its description using text for LCL and text muted foreground. The emotion slider section is where the user interacts. A flex justify between div displays our emotions mapped emoji markers. Each marker is cursor pointer, and its opacity changes based on how close its value is to the mood score, visually guiding the user. Clicking an emoji marker directly sets the mood score. Below these markers is the Shadcn UI slider component. Its value is bound to mood score, and on value change updates the state as the user drags it. It ranges from 0 to 100 with step 1. Finally, the submit button class name equals W full, is styled to take up the full width. The button text here is save mood. Now let's head back to your dashboard page .tsx. You'll need to import mood form at the top. Then, you'll need to add a new state for tracking the saving process. This is saving mood state will be a Boolean flag that we set to true when we start saving the mood data and false when it's done. Next, we'll create the handle mood submit function. This handle mood submit function is an asynchronous operation. It first sets is saving mood to true. Inside the try block, you'd place your actual API call, like save mood data, to send the mood score to your backend. If the call is successful, it then closes the mood modal. The catch block logs any errors, and the finally block ensures is saving mood is reset to false, whether the operation succeeded or failed. Finally, back in the mood form component you've integrated into your dashboard, make sure to pass handle mood submit to its onSubmit prop, and also pass is saving mood to its isLoading prop. This connects your form's submission to your data saving logic and updates the button's disabled state. Now let's scroll all the way up and uncomment the set show mood modal on click function. This action will enable the modal to open. On the local host, when we click on the track mode button, we can now see our mode modal appear. Perfect. Next up, let's create the activity logger component to allow users to record their wellness activities. Inside your components folder, create a new file called activitylogger.tsx. Within this new file, start with your use client, directive, and then import the necessary modules. We'll define an array of activity types that users can choose from. This simple array provides IDs and display names for common wellness activities. Now, let's define the props for our activity logger component. The open prop controls the modal's visibility. On open change is a callback to update that open state, and on activity logged is a function that will be called after an activity is successfully logged. Now, we'll export our activity logger functional component, destructuring its props. Inside the component, we'll manage several states for our form fields. These states will hold the isLoading status of the form, the type of activity selected, its name, duration, and any description the user provides. Next, we'll create the handle submit function that runs when the form is submitted. The handle submit function first calls a prevent default to stop the browser from reloading the page. It then performs basic validation, alerting the user if type or name are missing. It sets isLoading to true. Inside the set timeout, simulating an API call, it resets all the form fields, shows a success alert, closes the dialog, and triggers the onActivity logged callback if it's available. Now let's lay out the UI using a dialog. Here's sets up the basic structure of our activity logger modal. It uses ShadCN UI's dialog components with open and unopen change controlling its visibility. The dialog header contains a clear dialog title, log activity, and a helpful dialog description. Inside the dialog content, we'll create a form element linking it to our handle submit function. This form tag is crucial. OnSubmit equals handle submit ensures our JavaScript function runs when the form is submitted. The class name helps center the form, sets it as a flex container, useful for aligning buttons at the end, and adds some spacing. Within this form, we'll add our first input group for activity type. This div uses space y2 for spacing. The label component clearly labels the field activity type. The shard CNUISelect component creates our dropdown. Its value is bound to our type state, and on value change updates the type state when an option is selected. Inside select content, we map over our activity types array, creating a select item for each one using its ID as the value and name for display. Next, we'll add the input field for the activity name. This provides a label for name and an input component where the user can type in a descriptive name for the activity. Its value is bound to the name state, and onChange updates it as the user types. A placeholder provides helpful examples. Finally, we'll add the Save Activity button. This button is explicitly type equals submit, meaning it will trigger our form's handle submit function when clicked. It takes ww full for full width and is disabled when its loading is true, preventing accidental duplicate submissions. Now head back to your dashboard page .tsx. You'll need to import the activity logger component there. Over here, let's add the activity logger state. Then find where you define the handle AI check-in function, or create it if it's missing, and make sure it sets your state to open the activity logger. So that is the function over here. And with that, when you click the check-in button on your local host, you should now see the fully functional activity log modal. Let's now move on to creating the chat session page for our AI therapist. Inside your app directory, create a new folder called Therapy. Then, inside Therapy, create another folder named Session. The square brackets indicate a dynamic route in Next.js. Finally, inside Session, create a file called page.tsx. Start page.tsx with use client to ensure it's rendered on the client side, then import all the necessary modules. Make sure to quickly install React Markdown in your terminal if you haven't already. This library is crucial because it will help us format the AI's responses in our UI, converting Markdown syntax into beautifully rendered HTML. Now let's define our main therapy page component. Inside, we'll define several state variables to manage our chat interface. These states will handle the user's input message, whether the AI is typing the array of messages in the chat, a mounted flag important for client-side rendering effects, and overall is loading state for the chat, and whether the chat paused. We'll use a useEffect hook to set the mounted flag once the component has rendered on the client. This is a common pattern to ensure client-side only logic or animations are applied after React has hydrated the component in the browser. For auto-scrolling to the bottom of the chat, we'll use a useRef. This messages and ref will be attached to a div at the very bottom of our chat display, allowing us to programmatically scroll to it. Here's our scroll to bottom function. This function will scroll the chat area down. The set timeout ensures that any new messages have been rendered into the DOM before we attempt to scroll, and a useEffect to trigger that scroll. This hook ensures that the chat automatically scrolls to the bottom whenever new messages are added, but only after the AI has finished its typing, so you see the complete response. Before we render the UI, let's define a framer motion animation variant for a glowing effect. This glow animation variant creates a mesmerizing, pulsing glow that will apply to elements to give them a magical AI feel. Now let's return the main structure of our chat page. It starts with a main container div and a header section. The outer div, flex1, flex column overflow hidden, BG white dark BG background rounded LG border, makes our chat interface take up available space, stacks its content vertically, and gives it a clean bordered rounded corner look with dark mode support. The chat header P4 border B flex item center justify between has padding, a bottom border, and uses flexbox to neatly arrange its items. Inside, a div holds our AI bot icon, a W8H8 rounded full div with a light primary background and a centered bot icon. Now, let's think about how to get to this chat page. Back on your dashboard page.tsx, locate the onClick function for the Start a New Therapy button. Let's create a function called handle start therapy that will take us to this chat page. First, you'll need to import useRouter from next/navigation at the top of your dashboard file. Then, initialize it. Now, define your handle start therapy function using router.push. With that in place, clicking your therapy button on the dashboard will smoothly navigate you to our new AI therapist chat page. Back inside therapy/session/page.tsx, we display AI therapist as a bold H2 and the dynamic count of messages length in smaller muted text. You'll instantly see this header on your local host, proudly displaying the bot icon and AI therapist. We need to conditionally render the chat content. When there are no messages, we'll display a welcoming screen with suggested questions. This large block is what your users will see when they first open the chat, before any messages have been exchanged. The outermost div, flex1 flex items, center justify center P4, ensures the content is centered on the screen. The max W2XL W full spacey 8 div acts as a content wrapper, limiting its maximum width and providing generous vertical spacing. Within the AI therapist heading section, text center space E4, we have a relative inline flex div that houses our animated AI avatar. The first motion.div creates a large pulsating blurred glow behind the AI therapist text using our glow animation variant. The core AI therapist text itself is within a relative flex items center gap 2 div. Notice the relative div around the sparkles icon. It contains 2 sparkles icons, one static and one motion.div that also uses the glow animation, making the sparkles themselves pulse. Below this, a p tag displays the inviting message, "How can I assist you today?" And now, when there is chat content, when messages.length is not 0, we'll display the actual message history. This dynamic section displays our chat messages. The outer div, flex1 overflow auto scroll smooth, makes the message area take up all available vertical space, adds a scroll bar if content overflows, and ensures smooth scrolling. The inner max W 3XL MX auto div centers the message content. We use animate presence initial equals false to handle animations as messages enter and exit the DOM. Inside, messages.map iterates through our messages array, rendering each one. Each message is wrapped in a motion div with a unique key derived from its timestamp that fades in and slides up, giving a smooth animation as new messages appear. The class name dynamically applies a slightly different background color, BG muted /30 for AI messages versus user messages, BG background. Each individual message, div class name equals flexgap-4, uses flexbox to lay out the avatar and the message content side by side. The div for the avatar conditionally renders either a bot icon for AI messages or a user icon for your messages with appropriate styling. The message text content flex1 space Y2 overflow hidden min2 rem displays the sender's label AI therapist or U and can optionally show a badge if the message has a metadata technique property, e.g. indicating a specific therapy technique used by the AI. The heart of the message content is React Markdown greater than MSG content, which takes the raw markdown in MSG content and renders it beautifully into styled HTML. Below the messages, there is typing, and D block is a conditional rendering that shows a typing indicator only when the AI is typing. This includes a spinning loader 2 icon. Finally, div ref equals messages is that special div we discussed earlier, attached to our messages end ref, so that our scroll to bottom function can easily bring the latest message into view. Now, let's work on the form for submitting new chat messages. We'll start by wrapping it in a div that will serve as our input area. This div provides a clear boundary at the bottom of the chat with a border T, top border. The BG background /50 backdrop blur creates a modern frosted glass effect by blurring content behind it, while support dash backdrop filter big background /50 ensures graceful fallback for browsers that don't support the blur effect. P-4 adds padding around the input elements. Inside this div, we'll define our form element, linking it to a handle submit function, which you'll implement to send messages. The onSubmit equals handle submit attribute connects our form submission event to the handle submit JavaScript function. The class name helps center the form horizontally, limits its maximum width, sets it as a flex container, flex gap 4 for aligning input and button, and ensures items are aligned to the item's end bottom. It's also relative for positioning the send button. Inside the form, we'll have a div to wrap our input field. This div takes up the available horizontal space. Flex 1 within the form is relative for positioning the send button inside it and acts as a group for Tailwind hover effects. Now, let's add the core of our chat input, the text area, and the send button. This text area serves as our multi-line chat input. Its value is bound to the message state, and on change updates that state as the user types. The placeholder changes dynamically based on each chat paused. It has extensive Tailwind CSS styling, W full resize, non-rounded 2XL border BG background for basic looks, P3 PR12 for padding, extra PR12 to make space for the send button, and min h-48 pixels, max h-200 pixels. So it starts at a reasonable height but can expand up to 200 pixels before scrolling. Focus styles provide visual feedback and transition. All makes style changes smooth. It's disabled if the AI is typing or the chat is chat paused, and its appearance changes with opacity 50 cursor not allowed. The on-key down handler is a neat trick. If the user presses enter and not shift plus enter, it prevents a new line and instead triggers handle submit. The button acts as our send button. Its type equals submit, making it part of the form's submission. It's styled as an icon button with size equals icon. Its class name positions it absolutely to the bottom right of the text area's container, giving it H-36px, W-36px, and rounded XL corners. It has a primary background that darkens on hover with a subtle shadow. It's disabled if the AI is typing, the chat is chat paused, or the message is empty. The group hover.scale 105 group focus within scale 105 makes the button subtly enlarge when the text area, its group parent, is hovered or focused, which is a nice touch. The on-click handler explicitly prevents the default button behavior and then manually calls handle submit. The send icon is displayed inside the button. And there you have it. With all these pieces in place, you now have a beautiful and interactive chat interface. This has been an incredible journey. And with this front end complete, we're now ready to move on to the backend. First things first, let's create a dedicated folder for our backend code. In the root directory of your project, create a new folder and name it backend. Now open your terminal. We need to navigate into this new backend folder. Type the following command, cd backend. This command simply means change directory to backend. It puts your terminal's current working location inside the backend folder. So any commands you run next will apply there. With your terminal inside the backend directory, let's initialize our Node.js project. Run this command, npm init y. This command is super handy. npm init stands for Node Package Manager Initialize, and the y flag tells it to automatically say yes to all the default questions. What it does is create a package.json file in your backend folder. If you now check your backend folder, you'll see this new package.json file. This file is like the manifest for your Node.js project. It contains metadata about your project, like its name, version, and description. And most importantly, it lists all the dependencies, the external libraries and packages your project relies on. Think of it as a recipe book for your application. Our backend will be built using ExpressJs, which is a fast and opinionated minimalist web framework for Node.js. It provides a robust set of features to develop web and mobile applications. It simplifies tasks like handling routes, requests, and responses, making it much easier to build our server. To install ExpressJS, use this command: npm install express. This command downloads the express.js package and its dependencies from the npm registry and adds them to your Node modules folder, then records it as a dependency in your package.json. Now let's create our very first Node.js server. We'll follow the hello world example from the express.js documentation. Create a new file called index.ts. Yes, TS because we're using TypeScript directly inside your backend folder for now. We'll move it into a source folder shortly. We are going to import Express from the Express package. Then we'll create a constant for our app to instantiate an Express application. We'll define the port our server will listen on, add middleware to parse JSON bodies from incoming requests, define a route for a GET request to the route URL. You might notice some red wavy lines under rec and res initially. This is because we are using TypeScript and it wants to know the types of these variables. We explicitly import request and response types from the Express package to fix this, making our code type safe. And finally, start the server to listen for incoming requests. Before we test our server, we're going to install a super helpful tool called NodeMon. What is NodeMon? NodeMon is a utility that monitors for any changes in your source code and automatically restarts your server. This is incredibly useful during development, as it saves you from manually stopping and restarting your Node server every time you make a change, drastically speeding up your workflow. Let's install NodeMon. Since it's a development tool, we'll install it as a dev dependency. We will type npm install savedev NodeMon inside our terminal. After installing, open your package.json file. We need to edit the scripts section to tell npm how to use NodeMon. Look for the scripts object and modify it like this. Now, you might recall an earlier instruction to create index.ts directly in backend. We need to fix a potential error that will arise from our package.json script. If you were to run npm run dev right now, you'd get an error because our script is pointing to src index.ts, but we don't have a src folder yet. So let's quickly create one. In your backend directory, make a new folder named source. Then drag and drop your index.ts file inside this src folder. One more crucial step before we run our server. We're using TypeScript, so we need to install TypeScript itself into our project. We'll also install it as a dev dependency using npm install savedev TypeScript. After installation, you'll see a tsconfig.json file appear in your backend directory. This is TypeScript's configuration file. For now, the default settings are fine. Now that everything is set up, let's run our development server. You should see output in your terminal indicating that NodeMon is starting the server on port 3001. To test our API, we're going to use a tool called EchoAPI. What is EchoAPI? EchoAPI is a comprehensive API development platform designed for collaboration. It offers essential features like API debugging, creating API specifications, writing and running tests for your APIs, stress testing, automatically creating API docs, and many other exciting features. Go to the EchoAPI download page, download the version for your operating system, and open it. On the EchoAPI interface, make a GET request to the endpoint localhost port 3001. This request will hit the root endpoint we defined in app.get in our index.ts file. and you should see the simple message "Hello World" returned as a response. Success! Our first Node.js server is up and running. Let's quickly create another endpoint to see how easy it is. In your index.ts file, add this new app.getRoute. Now, in EchoAPI, make another GET request to localhost port 3001 /API/chat. You should receive the friendly response. "Hi, how may I help you today?" Excellent. Next, we're going to use ingest for our AI agent. What is ingest? Ingest is a powerful developer platform that provides a reliability layer for building applications. It particularly focuses on durable execution, ensuring your long-running functions complete even if your server restarts. Event-driven workflows, building complex processes that respond to specific events. Observability, giving you insights into how your functions are running. Essentially, ingest helps us build robust, scalable, and observable backend processes, which is perfect for managing our AI agent's complex tasks. Let's quickly navigate to the docs section on the ingest website. On this page, we'll learn how to set up ingest, which will eventually lead us to building our AI agent with it. Under the Quick Start section, make sure to select Node.js, since that's what we are using, and then follow the steps accordingly. Let's begin by installing ingest. After installation, we need to run the ingest dev server. This is a local server that ingest provides for development, allowing you to test and debug your ingest functions. Use this command. You'll be prompted to type Y to install the ingest CLI command line interface. Once installed, you'll see a URL in your terminal. Copy this endpoint and paste it into a new tab in your browser. This is your ingest dev server dashboard. We'll discuss more about what this dev server is used for very soon. Back to the ingest documentation. The next step is to create an ingest client. This client will allow our Node application to interact with the ingest service. Inside the src folder of your backend directory, create a new folder called ingest. Within that, create a new file named index.ts. In this new src/ingest/index.ts file, we'll import ingest and then copy the client setup example from the ingest docs. We're going to change the ID from the default My App to AI Therapy Agent. This ID is how your application identifies itself to the ingest service. Next, we need to set up the ingest HTTP endpoint within our main Express server. This endpoint is what the ingest service will communicate with to trigger and manage your functions. Go back to your src/index.ts file. At the top, you'll need to import serve from ingest/express. You'll also need to import our ingest client and functions, which we haven't created yet, but will soon, from our src ingest index.ts file. Add this line to your src index.ts file. Typically, after your other app use middleware, you'll notice we're importing something called ingest functions. To accommodate this, let's go ahead and create a functions.ts file inside your src ingest/ folder. This functions.ts file will be where we define all our specific ingest functions, like those for our AI agent. Inside src ingest functions.ts, we'll import our ingest client and then add a basic example function from the ingest docs. We will get back to this in a second. Now let's create a logger utility function. A logger is a software component that's used to record events, errors, and other important information during an application's execution. It helps developers understand what's happening within their code, debug issues, and monitor the application's health. We'll create a new folder called utils inside your src directory, and within utils, create a file named logger.ts. we'll use a popular login library called Winston. First, let's install it. Now, inside srcutils logger.ts, add this code. This code sets up a login system that creates a new Winston logger. By default, it records informational messages and anything more severe, like warnings or errors. Each log entry will include a timestamp and be formatted as a structured JSON object, making it easy to read and analyze. The system is also configured to send all error messages to a dedicated error.log file, while all general messages, info level and above, are saved in a combined .log file. This if block checks if our Node.js environment is not production. If we're in development, it adds a console transport. This means logs will also be printed directly to our terminal, but with colorized for better readability and a simple format, which is easier to scan than JSON in the console. Finally, we'll export our logger. Back in our main srcindex.ts file, let's import our logger at the top. We'll use it as a middleware, which I'll talk more about later. But for now, let's refactor our server start logic. Uncomment the previous app.listen call and create an optimized start server function. Inside the try block, we define our port, preferring an environment variable process .nv.port if available, otherwise defaulting to 3001. Then app.listen starts the server and our logger.info calls print helpful messages to the console and files, indicating the server port and the ingest endpoint. In the catch block, if any error occurs during server startup, logger.error will record it, and process.exit1 will stop the Node.js process, indicating an error. Now, when you run npm run dev, you'll see the importance of our logger. Instead of just console.log, you'll get nicely formatted log messages in your terminal and in the error.log and combined.log files in your backend directory. Let's do a quick cleanup. Back in srcingest we currently have a hello world function. We'll refine this later for our AI agent. For now, let's make sure the imports in src/index.ts correctly point to it. Okay, so we imported our main functions and gave them a new, more specific name, ingest functions. Now, within the ingest endpoint setup section, we will ensure that all references to those functions explicitly use this new name, ingest functions, for clarity and consistency. This simply means we are using the more descriptive title we just assigned. When you check the ingest dev server URL in your browser, you should now see your AI therapy agent app synced. If you navigate to the functions tab in the dev server, you'll see the hello world function we just created listed there. On the runs tab, you'll see details on any executions of this function. If you click on a run, you might see an output like hello undefined. From the hello world example, return as event body, which might not be using event data correctly yet, but don't worry, we'll refine this later. Next up, let's set up our MongoDB database connection. Go to the MongoDB website. You can sign up using your Google or GitHub account. If it's your first time using MongoDB Atlas, you'll be greeted with a welcome screen. Accept the privacy policy and click Submit. Next, we're going to create a new project. Click on New Project, give it a name of your choice, something like AI Therapist Agents, and then click Next. Finally, click Create Project. Once the project is created, let's create a cluster. Choose the free tier if you don't want to be charged. Give your cluster a name and proceed to create a deployment. After that, you'll need to create a database user, remember these credentials, and choose a connection method. We'll select the drivers option. One of the most important things on this page is the connection string URL. Copy this URL. It will be of use very soon. Then click Done. Now, back in your backend project, let's create a .env file in the root of your backend directory, the same level as package.json. Paste your MongoDB connection URL into this file. Now, back in your src index.ts file, we'll create a function called connectDB. But before we do that, let's create a new file inside our src utils folder named db.es. This file will encapsulate our database connection logic. We'll start src/util/db.ts by importing Mongoose. Mongoose is an object data modeling, or ODM, library for Node.js. It provides a way to define the structure of your application's data, making it much easier to work with MongoDB databases. It essentially sits on top of the raw MongoDB Node.js driver and offers features like validating data based on your defined structure, helping you build complex database queries, and allowing you to run custom code before or after database operations. So in your src utils db.ts file, you'll first import Mongoose and your logger utility. Next, you'll define your MongoDB connection string using the environment variable process.env.mongodb URI. Now let's create our connectDB asynchronous function, which will handle connecting to the database. The line await Mongoose, connect MongoDB URI is the core command that attempts to establish a connection to your MongoDB Atlas cluster using the connection string you provided. The await keyword ensures that the program pauses here until this connection process is either successful or fails. If the connection is successful, logger.info, open parenthesis, connected to MongoDB Atlas, close parenthesis, will record an informational message using our logger, confirming the successful connection. The catch error block is designed to handle any errors that Mongoose Connect might encounter, such as incorrect login details or network problems. Inside the catch block, logger.error logs the specific error using our logger for debugging purposes. Finally, process.exit1 terminates the Node.js program with an exit code of 1, which signals that an unhandled error occurred and the application could not start correctly. Next, back in your src/index.ts file, let's import connectDB at the top. Now, save all your files and run npm run dev again. In your terminal's console, you should now see connected to MongoDB Atlas, indicating that we've successfully established a connection to our database. One more important step, go back to your MongoDB Atlas dashboard. Under the Security tab, click on Network Access, then click Add IP Address and allow access from anywhere. While this isn't advisable for production environments where you should whitelist specific IP addresses, it will help save us from future connection errors during development. Next, let's define our Mongoose models. These models represent the structure of our data within MongoDB. Inside your src folder, create the following new folders: models, controllers, middleware, and types. Inside the models folder, create a file named user.ts. This will define the structure for our user data. We'll import Mongoose, document, and schema. Then we define our TypeScript interface for iUser. This interface extends document from Mongoose, meaning instances of iUser will have all the properties of a Mongoose document. This interface ensures type safety for our user objects, specifying that each user must have a name, email, and password. Next, we define the user schema, new schema. We create a new Mongoose schema, explicitly typing it with our iUser interface for strong type checking name. Type string, required, true. Name will be a string and is required. Email will be a string, required, and unique. meaning no two users can have the same email. Password will be a string and is required. Timestamps, true. This is a Mongoose option that automatically adds created at and updated at fields to our documents, which are useful for tracking when data was created or last modified. Finally, we export our user model. This line compiles our user schema into a model that we can use to interact with the user collection in MongoDB. Now let's create a file called session.ts in the models folder. This model will manage user sessions and authentication tokens. Import Mongoose, document, and schema. Then define our iSession interface. This interface defines the structure of a session document. User ID is a special mongoose.types.object_id that will link to our user model. Next, we define the session schema. This defines user ID as an object ID that refers to a document in the user collection. This is how we establish a relationship between session and user. The session token itself required and unique to prevent token collisions. Expires at the date and time when the session should expire, crucial for security. Device info, an optional field for storing information about the user's device or browser, like a user agent string. Last active, stores the last time this session was active, defaulting to the current time. Crucially, we'll add an index for automatic cleanup of expired sessions. This session schema index expires at 1, expire after seconds. 0 line tells MongoDB to automatically delete documents from the session collection when their expires at field reaches 0 seconds past its value. This is a powerful feature called a TTL index, time to leave, that helps manage session cleanup efficiently without manual intervention. Finally, we export our session model. Now, let's create our authentication controller. Inside the controllers folder, create a file named authcontroller.ts. This file will contain functions to handle user registration, login, and logout. We'll import our request and response types from Express and our user and session models. Then we'll import bcrypt.js. What is bcrypt.js used for? Bcrypt.js is a library used for hashing passwords. Hashing is a one-way cryptographic process that transforms a password into a fixed-length string of characters called a hash. The crucial part is that you can't easily reverse a hash to get the original password back. This is essential for security. Instead of storing plain text passwords, which would be a huge security risk if your database were breached, you store only their hashes. Let's install it. We'll also import JSON Web Token for creating JWTs, JSOD structures. Let's install that too. And remember to install the TypeScript types for these if your linter complains. Now let's create the register function. It's an async function because it performs database operations. This line destructures the name, email, and password properties from the incoming JSON request body. This is a validation check. If any of the required fields are missing, it sends a 400 bad request status with an appropriate error message. Constant existing user equals await user dot find one email. This command queries the database to ascertain if a user possessing the specified email address currently exists. If existing user is found, should an existing user with that email be located, the system dispatches a 409 conflict status, signaling that the email is presently in use. Constant hashed password equals await bcrypt.hashPassword 10. Here, bcrypt.js performs its function. It processes the plain text password, transforming it into a hash. The numerical value 10 represents the salt rounds, also known as the cost factor, which dictates the computational intensity of the hashing operation. A greater value denotes a slower, yet more cryptographically secure process. Constant user equals new user with name, email, password as hashed password. A new user document is then instantiated, incorporating the provided name, email, and critically, the hashed password. await user.save. This instruction persists the newly created user document to the MongoDB database. Response status 201.json. Upon a successful registration, the system returns a 201 created status accompanied by a JSON response. This response includes the new user's unique identifier, name, email, and a confirmation message. It is imperative that the hashed password is explicitly not transmitted back. Catch error. In the event of any unforeseen error during this sequence, the error is captured and the system dispatches a 500 server error response. Next, let's create the login function. If not email or not password, this checks if both email and password are provided. If missing, it returns a 400 bad request. Constant user equals await user.find one email. This tries to find a user with the provided email. If not user, if no user is found, it sends a 401 unauthorized response with invalid email or password. The message is kept generic for security. Constant is password, valid equals await bcrypt.compare password user.password. Here, bcrypt.js compares the plain text password with the stored hashed password securely. If not, is password valid? If passwords don't match, it returns a 401 unauthorized response with invalid email or password. Constant token equals jwt.sign. If credentials are valid, a JSON web token or JWT is generated. User ID, user.id is the token's payload, securely embedding the user's ID. Process.env.jwt secret or your secret key is the secret key used to sign the token. This must be strong and kept secret, ideally in an environment file. Expires in 24 hours means the token expires after 1 day, requiring relogin. Session creation, constant expires at equals new date, expires at .set hours, expires at .get hours plus 24. This calculates the session expiration for 24 hours later. Constant session equals new session, await session .save. A new session document is created and saved, linking to the user ID, token, expiration time, and device info from the request. Response.json. On successful login, it sends a JSON response with user details, the token, and a success message. Catch error. This catches any unexpected server errors. Finally, let's create the logout function. Const token rec.header authorization replace bearer. This line attempts to extract the JWT from the authorization header of the incoming request. JWTs are typically sent in the format bearer token string. So replace bearer cient removes the bearer prefix. If token, it checks if a token was actually found in the header. Await session delete. The tune token. Thus, if a token is present, it attempts to delete the corresponding session document from the database. This effectively invalidates the user's session, so that token can no longer be used for authentication. res.json message logged out successfully. Regardless of whether a token was found and deleted, it sends a success message to the client, confirming the logout action. This is because from the client's perspective, the user is now logged out. Catch error tab catches any server errors that might occur during the logout process. Now, inside your routes folder, let's create a new file called auth.ts. This file will define the API routes for our authentication logic. First, we'll import router from Express, not Express directly, but the router method from it, and then our register, login, and logout functions from our auth controller. Before we continue setting up routes, let's talk about middleware. We'll create some essential middleware first. Middleware functions in Express are like checkpoints in your application's flow. They can see and change both the incoming request and the outgoing response. They can also decide whether to continue to the next step or stop the process. This makes them incredibly useful for things like checking who a user is, keeping a record of activities, or dealing with errors. Let's create a new folder called middleware in your source directory. Inside this folder, create two new files, auth.ts and errorhandler.ts. Inside src/middleware/auth.ts, let's import the necessary types and modules. We need to extend the Express request interface to include a user property, which our middleware will attach. This declare global block tells TypeScript to extend the existing Express request interface. This way, after our auth middleware runs, we can access rec.user, which will hold the authenticated user's details, without TypeScript complaining. Now let's create our auth middleware function. This defines our asynchronous auth middleware. Next is a function that, when called, passes control to the next middleware function in the stack. First, this process extracts the security token from the request. If no token is found, it immediately sends back an unauthorized response. The token is then decrypted and verified using a secret key. If it's invalid or expired, an error occurs. Once successfully decoded, the user's ID from the token is used to find their record in the database. If no user matches that ID, an unauthorized response is sent, as the user account may no longer exist. A crucial security step then checks if an active session record still exists for this user and token. If not, it's an unauthorized response, preventing use of old or invalidated tokens. If everything is valid, the full user's information is attached directly to the request, making it accessible to subsequent parts of the application. The process then moves on to the next step in the request handling chain. Any failures during token verification or other errors result in an unauthorized response with a generic invalid authentication token message. Next, let's create our error handling middleware. In the source/middleware/errorhandler.ts file, add these imports. We'll define a custom error class called appError. This new class, appError, extends the standard error class. This allows us to create custom errors that carry extra information. It has custom properties, status code, status, and is operational. In its constructor, it calls the main error class to set the error message. It stores the HTTP status code, like 400 or 500. It dynamically sets a status string, fail for client-side errors, which are 400 codes, and error for server-side errors, which are 500 codes. The isOperational flag is crucial. It marks the error as operational, meaning it's an expected error that can be handled smoothly, like invalid input. This helps distinguish it from programming errors, which are bugs in our code and might need different handling, like restarting the server. A special line ensures the stack trace is correctly captured, pointing to where the app error was created, which is helpful for debugging. Now we'll define our main error handling middleware. This function acts as a centralized error handler. Express recognizes it as an error handler because it accepts 4 arguments: the error itself, the request, the response, and the next middleware function. If the error is an instance of our custom appError class, it means it's an expected operational error. For these app errors, it sends a response to the client using the error's status code and includes the status and message from our appError object. This provides specific yet user-friendly error messages. If the error is not an app error, it's considered an unexpected error, likely a programming bug or a system issue. In this situation, our logger records the full error details internally for debugging. For unexpected errors, it sends a generic 500 server error response to the client. This is a security best practice as it prevents sensitive internal application details from being exposed publicly. Now that we have our auth middleware ready, let's go back to our src root auth.ts file. First, import our auth middleware. Then, initialize the express router and define our authentication routes. This creates an instance of an express router. Routers allow us to group related routes and middleware, making our application more modular. Router.post/register. This defines a post endpoint at /register. When a request hits this endpoint, it will be handled by our register controller function. Router.post/login. Similarly, a post endpoint at /login handled by our login controller. Router, post, logout, auth, logout. This is a post endpoint at /logout. Notice the auth middleware before logout. This means that before the logout function is executed, the request will first pass through our auth middleware. This ensures that only authenticated users can trigger a logout. This line sets up a get endpoint at /me. Its purpose is to return the details of the currently logged in user. It uses the auth middleware first, so if the user is authenticated, the system can then send back the information in the response. Now let's bring everything together in our main src/index.ts file. First, we need to make sure our environment variables are loaded. At the very top of your source/index.ts file, import and configure .env. Next, we are going to configure our middleware. What are middlewares? As discussed earlier, middleware functions in Express are handlers that the system activates sequentially for every incoming request. They operate within the request response cycle, performing tasks like interpreting data in requests, managing user authentication, recording events, setting response headers, or compressing data. By linking them together, you can create powerful processing pipelines for your requests. We're going to install 3 widely used middleware packages: CORS, Helmet, and Morgan. npm install CORS, Helmet, Morgan. Now let's import and use these middlewares in your source/index.ts file, typically after the line that handles JSON body parsing. Using app.useCore enables cross-origin resource sharing, or CORS, for all incoming requests. In development, your front-end and back-end often run on different ports, which browsers block by default due to security. CORS allows your front-end to send requests to your back-end. For production, you would typically configure CORS to permit requests only from your specific front-end domain. Using app.useHelmet is a security middleware that helps fortify your Express applications by setting various HTTP headers. It provides protection against common web vulnerabilities like cross-site scripting and clickjacking. Using app.useMorganDev activates an HTTP request logger middleware. It records details about incoming HTTP requests to your console. The dev argument specifies a concise, color-coded format that is easy to read during development. Finally, right before your start server call, we'll initiate our authentication routes and also include our error handler. Let's continue defining our Mongoose models. Now let's create the activity.ts file in your src models folder. This model will define the structure for logging user activities. Import Mongoose, document, and schema. Then, define our iActivity interface. This interface lays out the required properties for an activity log entry. User ID. This is a unique identifier that connects this activity directly to a specific user type. A text string indicating the activity's category, for example, meditation. Name, a simple, understandable name for the activity. Description, an optional text field for more details about the activity. Duration, an optional number representing how long the activity lasted. Timestamp, the exact date and time the activity was recorded. First, the user ID is defined. This is a required unique identifier that refers to the user model. A database index is also created on this field, which significantly speeds up any searches or sorting operations based on the user's ID. Next, the type field is a required text string. It includes an enum feature, which is very important here. This restricts the allowed values for type to a predefined list, such as meditation or exercise. This ensures that all data stored is consistent and prevents any invalid activity types from being entered. The name of the activity is a required text string. There's an optional text string available for a description of the activity. The duration is an optional number field with a minimum value validator to ensure that the duration cannot be a negative number. The timestamp field automatically sets to the current date and time if no value is specifically provided. Additionally, the overall entry includes a mongoose option that automatically adds both a created at and an updated at field. Finally, we'll add another index to specifically optimize queries for a user's activities over time. This creates a compound index. It means that any database queries which first filter by the user ID and then sort the results by timestamp in descending order, showing the most recent activities first, will be executed very efficiently. After all of this is set up, we then export the activity model. Next, let's create the chat.ts file in your SRC models folder. This model will store our AI chat session messages. Import mongoose, schema, and document. We'll define two interfaces: iChat message for individual messages and iChat session for the entire chat session. This iChat message interface defines the structure of a single message within a chat session. It includes the role, user or assistant, the content of the message, its timestamp, and an optional metadata object which can store additional information relevant to AI responses, such as the technique used, a goal, or progress, which can be an array of mixed types. Now, the iChat session interface. This iChat session interface defines the structure of a complete chat session document, extending document to get mongoose properties. It holds a unique session ID and an array of iChat message objects. Next, we define the chat message schema for individual messages. Role. The role field is a required string that must be either user or assistant. This enforces valid message senders. The message content is a required string. Timestamp. The timestamp for when the message was created. Metadata. This defines the structure of the optional metadata subdocument. Technique, string, goal, string, progress, schema, types mixed, an array that can hold elements of any MongoDB BSON type. This is useful for flexible data that might not have a fixed structure. Now, we define the chat session schema for the overall chat session. Session ID, a unique string identifier for each chat session. Chat message schema. This is an array of subdocuments where each subdocument adheres to our chat message schema. This embeds the messages directly within the chat session document. Timestamps, ads created at and updated at to track when the chat session was created and last updated. Finally, we export everything. Lastly, let's create the mood.ts schema for tracking user moods. We'll import mongoose schema and document. Then define our iMood interface. This iMood interface defines the properties of a mood entry. Now we'll define the mood schema. User read links the mood entry to a specific user. Score. The mood score is a required number. strictly constrained to be between 0 and 100 using min and max validators. Note: an optional string note about the mood. Timestamp: the timestamp defaults to the current time. Timestamps: true, at created at and updated at fields. Then we'll add an index to optimize queries for a user's mood entries. This index is similar to the one in activity schema, optimizing queries that filter by user ID and sort by timestamp in descending order. Finally, we export the mood model. Now, let's go back to our controllers folder and create a new file called activitycontroller.ts. This file will contain the logic for logging user activities. We'll start by importing the necessary types from Express, our activity model, and our logger utility. Now, let's define our log activity function. This is an async function that takes rec, res, and next for error handling. We destructure the activity details from the request body. Note: difficulty and feedback were in your destructuring, but not in your iActivity interface or activity schema. If you intend to use them, ensure you update your model accordingly. This is where the auth middleware comes in handy. If the user is authenticated, our auth middleware would have attached the user object to rec.user. We safely access the judge ID from it. A basic check to ensure a user is authenticated. If not, it returns a 401 unauthorized response. A new activity document is created using the data from the request body and the authenticated user ID. The timestamp is set to the current time. Await activity. Save. The new activity document is saved to the MongoDB database. Created status is returned to the client along with the success flag and the saved activity data. If any error occurs during this process, it's caught and passed to our error handler middleware using NextError. Next, let's create the moodcontroller.ts file in your controllers folder. This will handle the logic for creating mood entries. We'll import the necessary types from Express, our mood model, and our logger utility. Now, let's define our createMood function. This is an async function designed to create a new mood entry. We destructure score and note, and potentially context and activities if your iMood and mood schema are updated to include them. From the request body, const user using rect user ID, we retrieve the authenticated user ID from the rec.user object, which is populated by our auth middleware. If user ID, a quick check to ensure the user is authenticated, returning a 401 if not. A new mood document is created with the user ID, score, note, and the current timestamp. Await mood. Save. The new mood entry is saved to the database. A log message is recorded. A 201 created status is returned along with the success status and the saved mood data. Any errors during this process are passed to our error handler middleware. Next, we'll work on the chat controller, but we'll come back to that file in a second. Let's move to our ingest folder and create a new file called aifunctions.ts. This is where we'll define the functions for our AI agent. Alright, let's get our AI functions set up. First, within the aifunctions.ts file, we need to import the ingest library. This is our core library for defining AI functions. So we'll import ingest. Next, we import Google Generative AI. This is the SDK that allows us to communicate with Google's Gemini AI models. Before we use Google Generative AI, we need to make sure the SDK is installed. Let's quickly check the Gemini Docs website to confirm the package name and installation command. There, you'll see the installation command. Copy this command. Now switch back to your terminal, paste the command and press enter to install the package. This ensures our project has the necessary library to interact with Gemini. Once the installation is complete, return to aifunctions.ts. Now, we'll initialize our Google Generative AI instance. This instance requires an API key to authenticate our requests to the Gemini API. For security, we'll retrieve this key from our environment variables. So we'll create a constant named Gen AI, which equals a new Google Generative AI instance with the API key set to process.env.Gemini API key. To get your Gemini API key, open your browser and search for Get Gemini API key. Click on the link that directs you to aistudio.google.com/app/API key or a similar Google AI Studio API key management page. On that page, click on Create API key or Get API key and choose your existing project. Once the API key is generated, copy it to your clipboard. Now return to your backend directory in your project. You'll need to create a .env file if you don't already have one. Open this .env file and add the copied API key like this. Gemini API key equals your copied API key. Remember to replace your copied API key with the actual key you just copied. This keeps your sensitive API key safely out of your codebase. With our AI setup complete, first, let's define our initial AI function, process chat message. This function will be entirely responsible for both handling and analyzing incoming chat messages utilizing the Gemini AI. This function will also be exported. The ID is process chat message, which gives this function a unique identifier within the ingest system. The data field specifies some important metadata for our function. This includes a display name, process chat message, and a list of steps it will perform. The analyze mood step specifically indicates that this function will involve a process of mood analysis. The async event is the core asynchronous function that ingest will automatically trigger when an event that matches this function's criteria takes place. When triggered, it receives an event object, which contains data from the initial trigger, and a step object, which is used for running any sub-steps within the function's process. It begins by extracting key information from the incoming event data: the message itself, the full conversation history, the current memory state, the user's goals, and any system prompts. Importantly, if the memory or goals are not explicitly provided, they default to a structured empty memory or an empty list of goals. It then logs that it is processing the chat message, including the message content and how long the conversation history is. Next, it runs a crucial sub-step called Analyze Message. Within this step, it selects the Gemini 2.0 Flash AI model. It builds a detailed prompt for the AI. This prompt instructs the AI to analyze the therapy message and provide insights. It explicitly demands that the AI return only a valid JSON object with no extra formatting or text. The prompt includes the user's message along with the context of their current memory and goals. It also clearly defines the required JSON structure for the AI's output, specifying fields like emotional state as a string, themes as an array of strings, risk level as a number, recommended approach as a string, and progress indicators as an array of strings. The system sends this prompt to the AI model and waits for its response. Once the response arrives, the raw text is extracted and logged internally for debugging. The extracted text is then cleaned by removing any code block indicators or extra spaces, ensuring it can be correctly interpreted as a structured JSON object. This clean text is then passed into a structured analysis. This successfully passed analysis is also logged. Finally, this passed analysis is returned from the Analyze Message step. Should any error occur during this specific AI analysis, the error is logged, but instead of stopping, the function returns a default neutral analysis. This ensures the process can continue gracefully. Following the analysis, it runs an update memory sub-step. In this step, the session's internal memory is updated based on the results of the analysis. If the analysis provided an emotional state, it's added to the user's profile in memory. If themes were identified, they are added to the session's conversation context. If a risk level was provided, the user's profile risk level in memory is updated. The modified memory object is then returned. Next, there's a check for high risk. If the risk level identified in the analysis is greater than 4, it triggers a trigger risk alert substep. Within this alert step, a warning is logged internally, indicating that a high risk level was detected in the chat message, along with the message and the specific risk level. Then it moves on to a generate response substep. Here, it again uses the Gemini 2.0 Flash AI model. It constructs another comprehensive prompt for the AI. This prompt incorporates the system's initial instructions, followed by a request to generate a therapeutic response based on the message, the analysis, the updated memory, and the user's goals. It guides the AI to provide a response that addresses immediate emotional needs, uses appropriate therapeutic techniques, shows empathy and understanding, maintains professional boundaries, and considers safety and well-being. The AI's generated response text is extracted and logged. This generated response text is then returned from the generate response step. If an error occurs during this specific response generation, the error is logged, but it returns a default supportive message instead of halting the process. Finally, the entire process chat message function, upon successful execution of all its steps, returns an object containing 3 key pieces of information: the AI's generated response, the full analysis object, and the updated memory state. In case any unexpected error occurs anywhere within the main processing block of process chat message, a comprehensive outer catch block handles it. This block logs the error, including the original message content, and then returns a complete default response. This default response includes a supportive message, a standard neutral analysis object, and the original memory state from the event data, ensuring that the system always provides a stable and consistent output, even in error scenarios. Okay, we're now implementing the Analyze Therapy Session function, which is located in the same AI functions.trs file. This function is designed to analyze the content of a therapy session. This is the Analyze Therapy Session function. It has a unique identifier of analyze-therapy-session. This function is specifically triggered by an event named therapy/session.created. It operates asynchronously, receiving an event object which contains data from the trigger and a step object used for running smaller, distinct operations, .created. It operates asynchronously, receiving an event object which contains data from the trigger and a step object used for running smaller, distinct operations. Inside its main processing block, it begins by running a substep called getSessionContent. This step's sole purpose is to retrieve the session's content, which comes from either therapy notes or a transcript found within the event data. Next, it executes a crucial substep named Analyze with Gemini. This step constructs a detailed prompt for the artificial intelligence. The prompt instructs the Gemini 2.0 Flash AI model to analyze the provided session content and extract insights. It explicitly requests specific outputs: the key themes and topics discussed, an analysis of the emotional state, any potential areas of concern, recommendations for follow-up actions, and clear progress indicators. It also firmly directs the AI to format its entire response as a JSON object. This constructed prompt is then sent to the AI model. Upon receiving the AI's response, the raw results are extracted. The response text is trimmed of any extra spaces. This text is then immediately passed into a JSON object. Crucially, if the AI's text response happens to be empty, it defaults to passing an empty JSON object to prevent any processing errors. The resulting analysis, now in a structured JSON format, is what this Analyze with Gemini step returns. Following the analysis, it runs a store analysis substep. Within this step, a message is logged confirming session analysis stored successfully. The analysis data itself is returned from this storage step. Then there's a conditional check. If the areas of concern property within the analysis exists and contains any items indicating that concerns were identified, it triggers an alert. This initiates a substep called Trigger Concern Alert. Inside this alert step, a warning is logged internally, stating concerning indicators detected in session analysis. This log includes the session's unique identifier from the event data and the specific concerns found in the analysis. A note indicates that this is where further custom logic for handling these alerts would be implemented. Finally, after all these operations, the entire Analyze Therapy session function returns an object. This object contains a message session analysis completed along with the complete analysis data. In case any unexpected error occurs anywhere within the main processing block of Analyze Therapy session, a comprehensive outer catch block handles it. This block logs the full error details, stating error in therapy session analysis, and then rethrows that error. Rethrowing the error ensures that it can be caught and managed by higher level error handling mechanisms elsewhere in the application, preventing an unhandled crash. So let's go ahead and export the process chat function and also export the Analyze Therapy session function. Then we move back to the main functions file. Right at the top of this file, we are going to import the artificial intelligence functions that we just created. We'll bring in functions as AI functions from the AI functions file. Then we get rid of everything else there and use a special operator to spread or export everything from the AI function. Now back in the chat.ts file, in it we're going to import all the necessary libraries and components. This includes request and response from Express, chat section from chat, and Google Gemini AI from Gemini AI. We'll also import v4 from UUID v4. UIDs are useful for creating unique keys in databases, session identifiers, and more. Then we are going to import the logger as well from the utils function. We'll bring in ingest from ingest index and user from the models. We also import the type objects from Mongoose. Next, we define the create chat session function. This function handles creating a new chat session. It first checks if the user is authorized. If not, it returns an unauthorized message. Then, it finds the user in the database. If the user isn't found, it returns a user not found message. It then generates a unique session identifier. A new chat session is created with this identifier, the user's ID, the start time, and an active status, and it's saved to the database. Finally, a chat session created successfully message is returned with the new session's ID. Any errors during this process are logged and result in a server error message. Then we work on the send message function. This function handles sending a message within an existing chat session. It extracts the session ID, the message, and the user's ID. It logs the message processing. It then finds the chat session for that user. If the session isn't found, or if the user isn't authorized for that session, it returns an error. It then creates an inest event for message processing, including the message, history, and the default system prompt for the AI therapist. This event is sent to inest. The system then generates an analysis prompt for the Gemini AI model, asking for insights like emotional state and themes formatted as a JSON object. The AI's response is received, cleaned, and passed into an analysis. This analysis is logged. Next, a response prompt is created for the AI, incorporating the system prompt, message, analysis, memory, and goals, guiding the AI to generate a therapeutic response. The AI's response is received and logged. The user's message and the AI's response are then added to the session's history, with the AI's response also including the analysis and progress metadata. The updated session is saved and a success message is logged. Finally, the system returns the AI's response, the analysis, and progress metadata. Any errors during this process are logged and result in a server error message. Next is the get session history function. This function retrieves the full message history for a given chat session. It gets the session ID and user ID. It checks if the user is authorized and if the session exists for that user. If not, it returns session not found or unauthorized. If successful, it returns the session's messages, start time, and status. Any errors are logged and result in a server error message. Next is the get chat history function. This function retrieves the message history for a specific chat session. It gets the session ID and user ID. It finds the session and verifies the user's authorization. If the session isn't found or the user is unauthorized, it returns an error. Otherwise, it returns only the messages from the session. Any errors are logged and result in a server error message. Now that we are done creating all these functions inside the chat controller, we are going to move to the route folder and create a file called activity.typescript. In this file, we are going to import express, auth, and log activity. Then we are going to start writing our root folder activity file. So we are going to initialize the router using the express router. Then we are going to use the router and have the router.useAuth. We're going to have the router.log, which is going to log the activity. And then we export the first router. Next, let's create the mood.ts file in the route folder. This file will manage all the web addresses related to user moods. Similar to the activity file, we import the router tool, our auth middleware for security, and our create mood controller function. The line router.useAuth is important. It secures all mood-related web addresses with authentication. Then router.post/ defines a post endpoint at the main path of this router. So when a post request is sent to /API/mood, our create mood controller function will activate. Finally, we export this router. We also create the chat.ts file for the route. Over here, we're basically going to do a very similar thing to what we did in activities. We're going to import express and also import all the controller functions from the chat controller file, like create chat section, send message, get session history, get chat section, and get chat history. We're going to import auth middleware as well. We're going to initialize the router and create a post and get request on this endpoint. This script sets up the web addresses for all chat related features. It imports express along with all the chat controller functions like creating sessions, sending messages, and getting history. It also imports the auth middleware for security. A router is initialized and the auth middleware is applied to all routes defined within this router. This means every chat-related request will first check for user authentication. A post request to /sessions will create a new chat session. A get request to /sessions / a specific session ID will retrieve details for that chat session. A post request to /sessions / a specific session ID / messages will send a new message within that session. And a get request to /sessions / a specific session ID / history will retrieve the full message history for that session. Finally, this configured router is exported, making these chat functionalities available through the application's API. Alright, so now that we've finished creating the chat route, we are going to head back to the main index.typescript file. We'll scroll down to where we configure the application's routes, specifically where we see the app.useRoute statements. Here, we will import the rest of our newly defined routes. Then, we will integrate them into the application's main setup. Once that's done, we can finally begin testing all these new functionalities using EchoAPI. We'll now dive deeper into testing our chat functionalities, then explore how EchoAPI's AI-powered documentation and test case generation features can make our development workflow even more efficient. First, as always, let's ensure our backend server is ready. If it isn't, open your terminal, navigate to the AI therapist agent dev/backend directory, and start the server using npm start. You should see logs confirming the server is listening on port 3001 and the ingest endpoint is available. We'll open the controller folder and select the auth controller. Copy the register function and paste it into EchoAPI's AI Intelligent Extraction API documentation tool. To do this, click the Create button, then AI Extract API Docs, and paste the function there. EchoAPI will automatically extract the API specification from the code, generating an endpoint ready for use. After a short wait, click Save. You'll see a post request with a raw body message. This is the exact raw body message required to register a user, matching the function we created. We'll first register a user, then log in, and use that authentication information to test the app's remaining features. Click the gear icon next to the default environment and add our localhost port 3001, then save it. This will automatically be added to every request since our endpoint isn't yet hosted on a production server. We'll start with the registration route, copy the auth register URL, and append it to the localhost endpoint. Next, we'll use EchoAPI's AI Generate Fake Data feature. Copy the object, paste it into the dialog box at the bottom right, and click the rocket icon. EchoAPI generates fake data which you can copy and paste into the body object to register a new user. Clicking Send now registers a new user. Let's create an endpoint for logging in. We follow the same procedure. Click Create. Copy the login function from the auth controller. Paste it into the AI Extract API docs and click Generate. EchoAPI automatically creates the API specification. After saving, copy the email used for registration. Paste it into the login object's email field and add the password. Clicking Send now logs in our user, returning the user ID, name, email, token, and a success message. We'll create a post response script to set a token to the responses token. This becomes a global variable, accessible for any protected route, avoiding manual token copying for each request. Next, let's use EchoAPI's single test feature. Under the Cases tab, the AI-powered test generation can create various tests, including API specifications and compliance checks. Click Generate Test Cases. EchoAPI provides all the parameters for route testing. This is a very cool and handy feature. We won't apply and test it now, but you can. EchoAPI also has a neat one-click complete doc feature. We'll use this to create full documentation for our login API. After a short wait, click Save and Share. On this page, clicking the share icon and opening a new tab reveals EchoAPI's clean and beautiful documentation, which is highly readable for developers, enhancing their experience. Back to our code, copy the function to log an activity, paste it into the AI extract API docs. And generate an API spec. Once done, we'll have the required object to generate an activity. We'll run our post script to get hold of the token. We'll use the AI generate fake data feature to create some data. Copy the object, paste it into the text area, and click the rocket icon. We copy the response and use it to replace what's in our object. Now we have cool data generated by EchoAPI. In the headers, we'll pass the token we just set globally in the post request. Okay, we're addressing an undefined variable error, which suggests our post script isn't saving the security token correctly. When we ran the script, it indicated that a variable named response was already declared. This was the problem. So we've changed that variable name to resp and run the post script again. Now we see a 200 message, which means the script is working correctly. Back in the log activity header, we can confirm the token is now available. Let's go ahead and run the request now. We now have a response from our server. EchoAPI has a great feature called batch update description. We'll use this for our data. Clicking batch update, value and description, and then update values, updates them. Clicking complete description, save to sync API body, we can now save the schema with the generated values. Let's create our last endpoint to record a mood. Click Create, then use the AI Extract API Docs feature. Paste our Create Mood function inside it and generate. Once complete, we'll test it out. We provide the expected values, a score, the note context, and the activity. Then move to the headers and select authorization. Since we already have a post script updating the token globally, we'll use bearer followed by the token in curly brackets. Send the request and we see success as true with data returned. Things are looking good. A single test isn't always enough. Sometimes you need a sequence of tests that depend on each other. On the main sidebar, let's click on the Tests tab and let's create a new test case, naming it Creating Mood. Here, we'll add an HTTP request step. We select the User Login API and Create Mood API. Okay, we'll click on the Add by Copy button. When we then click on the Edit button for the User Login API endpoint, we can confirm that our post script is still active. Now let's move back to the Mood API. Under the header section, we'll add an authorization entry and provide the bearer token using the global token we set with the post script. Save that. We realize we forgot to add a body object, so let's return to the Edit API modal and add a body for the mood. Score 7, note, context, and activities. We'll save it one more time and run the test. The test fails. The problem is we forgot to add a URL to the mood endpoint. So let's go back to the Mood API edit modal and add it. Run the test all over again, and this time we have a passed test. Now let's remove the authorization header, save it, and run the test again. This time the test fails. This is because the create mood API is dependent on the user being logged in and authorized. One cool addition to EchoAPI is the AI generate script feature. To access this, go to the pre-request tab, add a new task and select processing script. From there, you can use the generate script dialog to instantly create a script using AI. This feature allows users to input natural language descriptions of their scenario requirements and receive ready-to-use script code. It's especially useful for quickly generating custom scripts for tasks like extracting and setting variables, performing encryption or decryption, and asserting response bodies. Next, we have the AI Generate function feature. Under the Advanced tab, go to Public Resources and click on Functions. When you click the Create button, you can generate functions using natural language prompts like the examples provided. The AI Generate function feature enables users to describe functional requirements in plain language and receive clean standalone JavaScript functions generated by AI with no third-party dependencies. These functions are designed to be reusable and help developers rapidly implement specific logic. This brings us to the end of testing our API. Try EchoAPI now. The link is in the description. Alright, let's continue building our application. We are going to start by creating new API routes for the login, register, session, and chat functionalities. First, let's navigate to the app directory, right-click on it, and select New Folder. We'll name this folder API. Now, right-click on the newly created API folder and select New Folder again. This one will be named Auth. Inside the Auth folder, we need to create 3 new folders: Login, Register, and Session. Now, within each of these new folders, Login, Register, and Session, we are going to create a file named root.ts. Repeat this for Register and Session. Let's start by implementing the login functionality. Open the root.ts file inside the login folder. At the top of the file, we'll add our imports. We'll need next request and next response from next server. Now let's define our post function, which will handle the login request. This will be an asynchronous function that takes a next request object as its argument. Next, we create a constant for the request body. We then define a variable for the API URL, retrieving it from our environment variables. If it's not set, it defaults to the local backend server address, http localhost port 3001. Within a try-catch block, we initiate a post request to the authentication login route. The request method is post with content type set to application JSON, and the request body is sent as a JSON string. We then get the data from the response. If successful, we return this data with a success status. Any errors encountered are caught and returned. Inside the register folder, we create a new file called route.ts. This file will be very similar to the login setup. We copy the login code, paste it into the register file, and simply change the endpoint from login to register, keeping all other elements the same. We'll create a new root.ts file within a session folder. We'll return to its specific session retrieval approach later. Now, Let's create the chat folder inside the API auth directory. Within this, we make a session directory. Inside the session directory, we create another folder named session wrapped inside a square bracket. This structure enables us to dynamically render routes using the chat session ID. Inside this session ID folder, we create a root.ts file. Here we import next request and next response from the next server library and retrieve the backend API URL from our environment variables or default to HTTP localhost port 3001. Next, we define the post request function for the chat session. Within its try-catch block, we extract the authorization header. If no authorization header is present, we return an error indicating it's required with a status code of 401. We then create a variable to hold the response from fetching the chat session. A post request is sent to create a new chat session with the method set to post, content type as application JSON, and the authorization header included. If this response is not successful, we create an error variable and return the error message. Otherwise, we store the received data and return it as a JSON response. Any errors encountered are caught and potentially rethrown. Inside the session ID folder, we create a root.ts file. Then, within this session ID folder, we also create a new folder named history and another folder named message. Please note, the message folder should be a direct child of the session ID directory, not inside the history directory. All these new folders, history and message, will also contain their own route.ts file. We import all necessary files and define an asynchronous get function. This function takes a request object, specifically accessing the session ID from its parameters. Within a try-catch block, it extracts the session ID. It then fetches the chat session history from our backend using this session ID. If the fetch is not successful, an error is thrown. Otherwise, the data is stored and returned as a response. Any errors are caught within the block. Next, we create a post request to add a new message. Within its try-catch block, we extract the session ID from the parameters and the message content from the request body. If no message is provided, we return an error with status 400. Otherwise, we send a post request to create this new message. If the backend response is not successful, we throw an error. If successful, we return the data received from the backend as a JSON response. Any errors during this are caught. Finally, in the history folder, we create root.ts. Here, we import necessary files and create a function to get the history. It will have parameters to get the session ID. Within a try-catch block, it extracts the session ID from the parameters. We then log the chat history for that session ID. A response variable is created to fetch the session history using the session ID. If the response is not successful, an error is thrown and an error message indicating failure to get chat history is returned. If successful, we format the messages. We use a mapping function to loop through all the data received from the backend, format it, and extract the role, content, and timestamp. This formatted message is then returned back to the caller as a JSON response. Any errors are caught and handled. Inside the same API folder, Within the auth directory, there's a folder named me. This folder is designed to retrieve user details, especially the authentication token. If you haven't created this file, do so now or follow along with the GitHub repository. Navigate to the me directory, and inside you'll find a route.ts file. Within this file, you import next request and next response from next server. Inside the get request function, a variable gets the API URL from the backend API URL in the environment file, or it defaults to the localhost port 3001 endpoint. The token is grabbed using the request object, accessing the header method and the get function. If there is no token, a no token provided message is returned with a status code of 401. Within the try catch block, a constant is created to get the user details at the auth/me endpoint. Headers are provided with authorization set to the token. A variable named data is created to hold the data from the responses. This data object is then returned using the next response.json. Any errors caught are handled gracefully by the next response. What we're doing now that we've created the Next.js API routes is establishing a utility function. This function will serve as the interface to manage the connection between these API routes and the application itself. So we create a lib folder in the root directory. Inside this lib folder, there's an API folder. Within it, you'll find activity.typescript, auth.typescript, chat.typescript, and mood.typescript. Let's start with activity.typescript. These files are available on the GitHub repository, so please clone it and follow along. I won't rewrite every single line because these are steps we've covered throughout the course. In the activity.typescript file, a function called logActivity is exported. This function is responsible for logging or saving an activity. It accepts data as a parameter and is an asynchronous function that returns a promise. The promise type accepts a boolean for success and any data type for the data. It gets a token from local storage. Then it sends a post request to the API/activity endpoint using the fetch API. If there's no response, it returns failed to log activity. Otherwise, it returns the response using the response.json object. Next, we move to the auth.typescript file. Here we have the register user function, which accepts the name, email, and password as arguments. This function sends a post request to the API auth/register endpoint to register the user. If the response is not successful, it returns an error message stating registration failed. Otherwise, it returns the registered user using the response.json object. We also have the login user function, which accepts email and password as arguments. It sends a post request to the auth.login endpoint. If there's no response, it returns login failed. Otherwise, it returns the response as JSON object. Next, we move to the mood.typescript file. Inside, we have an interface called mood entry, which defines a number type for the score and a string for the note. The track mood endpoint is responsible for saving the mood. It accepts data as an argument, which is a promise, indicating a boolean for success and any data type for the data. It gets a token from local storage because this endpoint requires authorization. It then sends a post request to the API/mood endpoint. If the response is not successful, it returns an error. Otherwise, it sends the data back to the caller. Now, in the chat.ts file, we have the chat message interface, which defines fields for the role, content as a string, and timestamp as a date. It also includes metadata, which comprises the technique as a string, goal as a string, progress as any, and analysis, which contains emotional state, theme, risk level, recommendation approach, and progress indicator. We also have an interface for chat section defining the session ID, messages, creation time, and update time. We expose another interface, the AI response interface, which will also have a message, a response analysis, and metadata. Then we create a constant to get the base API URL. Here, we use the environment variable process.env.nextPublicAPI URL, or a fallback to the backend URL. A function is used to get the headers, ensuring we don't recreate them repeatedly. It sets a constant for the token from local storage and returns the content type and authorization. In the create section function, we send a post request to the chat section to create a new chat section. If the response is not successful, an error is thrown. Otherwise, the data is returned back to the caller. We also have the send chat message function, which accepts a session ID and a message as a string. This function sends a post request to sections/session ID/messages. If the response is not successful, an error is thrown. Otherwise, the data is returned back to the caller. Any errors encountered are caught. The getHistory function also accepts the session ID. It sends a get request to the endpoint chat section/session ID/history. If there is no response, an error is thrown. Otherwise, the data is returned to the caller. If the format of the chat history response is incorrect, an error is thrown. Finally, the data is mapped, extracting the role, content, timestamp, and metadata, and then returned to the caller or the front-end function. We have the getAllChat section function. Here, a constant response variable gets the chat section. We include the headers using the getAuthHeaders function to ensure we can access the chat section since this route is protected. If there is no response, an error is thrown. Otherwise, the data is returned to the caller. We map the data and create variables for created at and updated at. We use the new date object and for data from the database, like session.createdAt. If no variable comes from this side, we default to using the date.now function. From the date object, we return the session, spreading its properties, along with created at, updated at, messages, and timestamp. Any errors are handled. Now that we've set up all our API utility functions, let's move to the session context.ts file inside lib/context. This file will manage our user session and authentication state. First, we use client because this will run on the client side, and we import all necessary items from React. These are essential for creating our section context. We create an interface for the user. We also import the useRouter hook. Then we have the interface for the section context type. We define the section provider function, which accepts children. This function creates state variables for the user and for loading status. The router is obtained using useRouter. Here we have the check section method, which gets a token from local storage. If there's no token, the user is set to null, loading is set to false, and the function returns. Otherwise, user data is retrieved using the API auth/me endpoint, passing the headers. If the response is successful, the user state is set to the save user data. If not successful, the user is set to null and the token item is removed from local storage. The logout function, if a token exists, sends a post request to the API auth/logout endpoint to log out the user. Finally, it removes the token from local storage. Now, when we scroll down, we'll see a useEffect hook. This hook is specifically used to initialize the check session method. Following that, we have the session context provider. This provider returns a value containing the user's data, loading status, whether they are authenticated, a logout function, and the check session method. The session context provider also includes children props. This is because we will use it to wrap around other providers, which will eventually be used within the application's layout. Finally, we export this context. Let's go into the component directory and find the provider.tsx file. Inside this file, we're going to import the section provider as NextAuth section provider from NextAuth React. Additionally, we'll import the section provider again, this time as custom section provider from the section context we just created. Here, we'll wrap both the NextAuth section provider and the custom section provider around the theme provider. Next, we move to the app directory and locate the layout file. Since we have our providers wrapped around the layout, it means we'll gain access to both the custom context section and the NextAuth provider. Finally, let's change the title of the application to AI Therapy Agent and set its description to your personal AI therapy companion. Alright, let's connect our backend authentication to the front end. We'll start by integrating the user signup functionality. We start by adding an error state and a loading state. We then define a handle submit function and a synchronous function to manage user signup. This function prevents the page from refreshing after submission. It first clears any existing error message. If the password doesn't match the confirmation, it sets an error. Otherwise, it sets the loading state to true, which will display a spinner on the sign up button. Inside the try-catch block, we initially log the user's name, email, and password. To make this work, we move to the form component, add an onSubmit event, and pass our handle submit function. We change the button's type to submit and disable it when the loading state is true. The button's text will conditionally render signing up if loading or sign up otherwise. On our local host at port 3000 on the sign up page, we can inspect the console. After entering details and clicking sign up, we see the logged information. If we enter a wrong password, the system should set an error state indicating the passwords don't match. To display this, we add a paragraph element right before the button, which renders the error message if the error state is present. Now, inside the try-catch block, we call the register user function from our auth.typescript file in the lib folder. This registers the user via the defined API. We provide the user's name, email, and password as arguments. Then, upon successful registration, we push the user to the login page. In the catch block, any errors from the backend are caught and set to the error state. and the loading state is finally set to false. Since the router isn't configured yet, we import useRouter from Next navigation and initialize it. When we test this on localhost, entering username, email, password, and confirm password, and clicking on sign up button, we are successfully taken to the login page. Currently, logging in won't work as the functionality isn't hooked up. So in the page.tsx file of the login page, we add error and loading states. We import and configure useRouter at the top of the state definitions. We create a handle submit function which, like in signup, prevents default page refresh. Inside, we set loading to true and clear any error messages. Within a try-catch block, we call the login user function from the auth.typescript file, passing email and password. The response from login user includes a token, which we store in local storage. We then import the useSection hook from the lab context useSection hook. Before using it, we destructure the checks section user function from the hook and call it right after setting the local storage item. After a brief delay of 100 milliseconds, we redirect the user to the dashboard page and handle any error that may occur and set loading to false in the finally clause. We add the handle submit function to the onSubmit event. Right before the button, we add an error display for any login errors and conditionally render its text based on the loading state. Now, when we sign in, we gain access to the dashboard. Next, we'll conditionally render a logout button in the header if the user is logged in. In the header.csx file, we import the useSection hook from the context. We destructure is authenticated and log out user from it. We scroll down to where the theme toggle and sign in button are located. Right after the theme toggle, we add a condition. If the user is authenticated, we render a log out button, otherwise we render the sign in button. Before the log out button, we add a start chat button that will take the user straight to the dashboard. Then we move to the logout button. Inside the logout button, icon and text like sign out. The on-click action for this logout button will come from the logout user function provided by the context. We add a console log to check the S authenticated and user status. If the console shows authentication as false and user as null, we log in again. After refreshing, the user details appear, and the sign out button is correctly rendered on the navigation bar, confirming authentication is working perfectly. Now let's move to the dashboard page.tss file. Here, we'll render the user's name in the welcome back section. To do this, we import the useSection context and initialize it. We destructure is authenticated, log out user, and user from useSection. Upon refreshing the page, we now see welcome back test user 3, displaying the logged in username. Next, we'll connect the mood form to the backend. We navigate to the mood directory and open the moodform.tss file. In the mood component, we import use section and destructure user authentication loading from it. We then create a handle submit function. This function first checks if the user is authenticated. If not, it alerts authentication is required and redirects the user back to the login page, then returns. If authenticated, it enters a try-catch block. Inside, it sets the loading state to true. It then checks for the token implicitly. As part of sending the request, it sends a post request to the API mood endpoint using the fetch API method, passing in the mood score. If there is no response, it throws an error. Any other errors are also handled. Then we create a variable named data to capture the response. We alert the user that the mood track was successful and call an onSuccess function. In the catch block, we alert the user with a failed message. Finally, in the last clause, we set the loading state to false. Now, let's scroll down to the button. We'll add an on-click event called handle submit and disable the button while it's loading. This prevents accidental double submissions. We also conditionally render the button's text based on the loading state. After saving this, we click the track mood button, select any mood, and click Save Mood. The mood track successfully message appears. Clicking OK confirms it's saved in the database. So let's work on the final piece of our application, the AI therapist page, which is our chatting interface. We import chat message, get all chat section, and chat session. We also import scroll area from shard CN. To install this, navigate to the shard CN website, find the scroll area component, copy its installation command, and run it in your terminal. We initialize parameters using the useParams function and create a state to hold the params section ID. Inside, we create a new section state that will store all our chat sections. Then, we define a handle new section function, which is asynchronous. Its purpose is to create a new chat section using the create chat section await function we already have. A constant for the new section is created, including the session ID, messages, and creation and update dates, all initialized to new date objects. We then update the section state by spreading the previous sections and appending the new ones. The session ID is set to the newly created one, and messages are set to an empty array. The URL is updated by using window.history.pushState. We do it this way and set loading to false. In the catch block, we either throw or console log any errors. We also initialize the chat section and load the chat history. To ensure our chat app is always ready, whether it's a new session or an existing one, we'll use a useEffect hook. This hook will run when the component mounts and whenever the session ID changes. This useEffect contains our initChat asynchronous function, which runs when the component mounts and whenever session ID changes. It first sets its loading to true. If session ID is not set or is new, the function logs that it's creating a new session. It then calls createChat session, which would be an API utility to create a new session on the backend. Upon success, it updates the local session ID state and, importantly, uses window history push state to update the browser's URL to /therapy/new session ID. This keeps the URL in sync with the current chat session. It then calls getChatHistory session ID to fetch messages. It ensures the history is an array and formats the timestamp strings into date objects, which is often necessary for proper rendering and manipulation in the front end. If any errors occur during loading, it logs them and displays a user-friendly message to the user. Finally, setIsLoading false always runs to hide the loading indicator. To power our sidebar, with a list of all available chat sessions, we'll use another useEffect hook. This one will fetch all sessions from the backend. This useEffect defines an async function load sessions. It calls getAllChatSessions, an API utility to fetch a list of all chat sessions from the backend and then update the local sessions state. We've set messages as a dependency here. This is a clever trick. By making messages a dependency, this useEffect will rerun whenever a new message is added or the message history changes. This helps ensure that your sidebar session list stays updated, particularly when a new session gets its first message, making it identifiable. Now let's work on the handle submit function, which is responsible for sending user messages to the AI and processing the AI's response. This handle submit function is the heart of our chat interaction. It starts by preventing default form submission and trimming the user's message. It includes several guard clauses to return early if the message is empty, the AI is already typing, the chat is paused, or there's no session ID. These checks prevent unnecessary API calls and ensure a smooth user experience. If all checks pass, it immediately clears the input field, set message, and sets set is typing to true to show a typing indicator. Inside the try block, it creates a user message object and optimistically adds it to the messages state using set messages state. This makes the user's message appear instantly, improving responsiveness. The raw API response is then passed. It gracefully handles cases where the response might be a stringified JSON. An assistant message object is created. It prioritizes content from AI response or AI response message and provides a default fallback if neither is available. Importantly, it also includes metadata such as analysis, technique, goal, and progress, all defaulting to safe values if not provided by the API. This metadata is crucial for displaying rich AI responses on the front end. Finally, the assistant message is added to the messages state. Set is typing, false hides the typing indicator, and scroll to bottom ensures the chat view is updated to the latest message. The catch block handles any errors during the API call or processing, logging them, and displaying a user-friendly error message in the chat itself. To enable users to switch between different chat sessions from the sidebar, we'll add a handle session select function. This handle session select function runs when a user clicks on a session in the sidebar. It first checks if the selected session ID is already the current session to avoid unnecessary reloads. If not, it sets its loading to true, fetches the chat history for that selected session ID, formats the timestamps, updates the messages state, sets the new session ID in our component state, and importantly, updates the browser's URL using window.history.push state to match the new session. This ensures direct links to specific sessions work and navigation history is preserved. It includes error handling, and a finally block to reset is loading. Now let's implement the visual part of our chat sidebar, which will display a list of all chat sessions. In your therapy.page.tsx file, right after the second main div in your return statement, which likely wraps your main chat interface, add this div. When you save this, you'll immediately see a new sidebar appear on your chat app, ready to display your chat sessions. This div with W80 flex column, border right BG muted /30 defines our sidebar. It has a fixed width, uses flexbox to stack its content vertically, and has a right border and a slightly muted background. The header P-4 border B contains a H2 for chat sessions and 2 buttons to create a new session. The first button is an icon-only ghost variant, using a loader 2 or plus circle icon based on its loading. The second button is a full-width outline variant, showing new session with a message square icon and a loader 2 while loading. Both buttons trigger a handle new session function which you'll need to define to create a new chat session. Below the header, the scroll area component wraps our list of sessions, allowing the list to be scrollable if there are many sessions. Inside the scroll area, we map through our session's state populated by our use effect to render each session as a clickable div. Key equal session.sessionAid is used for efficient rendering. The class name dynamically applies bg primary /10 text primary to the active session for visual highlighting, while other sessions use bg secondary /10. Cursor pointer hover bg primary /5 transition colors add interactivity. On click handle session, select functions ensures that clicking a session loads its history. Inside each session card, it displays a message square icon, a snippet of the first message's content or new chat, and a line clamp to snippets of the last message's content. Finally, it shows the total session.messages.length and the session.updated at timestamp. Formatted to be human readable using format distance to now from date fns, which you'll need to import. There's also a try-catch block around the date formatting for robustness. To complete our chat app, let's make sure our handle submit function is correctly linked to the send button. We already added type equals submit and on click handle submit earlier, so it should be all set. Now it's time to test it all out. In the chat input, type something like, "How do I manage stress?" Hit enter or click the send button. You should see your message instantly appear, followed by the AI typing indicator. After a short delay, you'll get a response from your AI therapist. Congratulations if you've gotten this far. This has been an incredible journey, bringing together the front end and back end of our AI therapy application. Everything is working perfectly. Now, we'll use Render to deploy the backend. Visit the URL provided in the description. Sign up using your preferred authentication platform. After logging in, you'll be taken to this page. Before hosting the backend on Render, we'll make some changes. Go back to your backend directory and open the package.json file. Inside this file, in the scripts section, add a new option called dev with tsc as its value. Next, change nodemon to node in the start script, change the source directory to dist, and update ts to js. This prepares our code to run correctly on Render. Then return to your .env file. Add entries for port, NodeEnv, Gemini API key, and JWT secret. On the render page, click the Add New Site button, then select the Web Service option. Here, we'll use the Public Git repository tab. Copy your backend repository from the GitHub link as provided in the description. Paste it and connect. We'll configure a few properties. For the root directory, type src. The sbuild command will be npm run build. The give start command as will be npm start. Select the hobby plan and then add your environment variables. Finally, click the Deploy Your Service button. This process will take some time to complete, and then your backend URL will be ready. We'll copy this backend URL to use for deploying our front end. For deploying the front end, visit vessel.com, log in or register, then click the Add New Project button. I've already pushed my code to GitHub. If you haven't, please do so. I'll select my AI Therapist agent repository. Now, add your environment variables. This will be the backend URL we copied from render. Then click Deploy. This will take a few seconds. It looks like the deployment is complete. Let's scroll up and see our deployed website. When we click the Visit button, it takes us directly to our newly deployed website. Everything works. We can actually log in. Beautiful. Thanks for watching the tutorial to this far. If you found this helpful, please subscribe and share it with others. Should you encounter any errors or have ideas for improvements, feel free to create a new issue in the project's repository. Your feedback is highly appreciated. Until then, see you in the next one.